Hello and welcome to my channel, The Curious Coder. If you're preparing for Java interviews or want to finally understand Java 8 the right way, this course is for you. In the next 3 hours, we are not just going to learn concepts, we are going to code everything live with real world examples that actually make sense. We'll start with powerful upgrades to interfaces like default methods and static methods, then move on to the core of Java 8, functional interfaces and Lambda expressions. From there, we'll break down the most important built-in functional interfaces, Predicate, Consumer, Function and Supplier. You'll also learn method references, then optional, and then master the most asked topic in interviews, Streams API. And finally, we'll cover the modern date and time API so you can stop struggling with legacy classes once and for all. Alright, so let's get started. So what is a default method? Default method is a method inside an interface that has some implementation. Before Java 8, we could only declare abstract methods inside an interface. We could not give them any body. But Java 8 allowed us to have fully implemented methods inside an interface. Now these methods can be defined using the default keyword, hence they are called default methods. Alright, so let me show you some examples. So we have an interface here named my interface, and let's say I just simply declare one method. Okay, like this. Now this is an abstract method because it does not have any implementation. Alright, so this is how we used to declare abstract methods in an interface. But now if I try to give it some implementation, you will see that it gives me an error that says interface abstract methods cannot have a body. Alright, so inside an interface, we are not allowed to give body to a method. Okay, now that was before Java 8. Now using Java 8, I can just simply add a keyword default, and now there is no compilation issue. Alright, so using this default keyword, I can declare the methods and I can also give them some body. Alright, so I'll just add a statement here. Let's say system.out.println. This is a default method. Okay, something like that. Alright, and I'll just call it using some child class. So let me create some my child class, and this implements the interface. And if I create an object of this class, my child class obj is equal to new my child class. Using this, I can simply call this method. Alright, great. So this statement is printed. Alright, so we have declared the method inside an interface only. I didn't give any implementation here in the child class, and using this, I can call the method. Alright, now why was default method introduced? What is the need for it? Default methods were introduced for backward compatibility. Before Java 8, if a new method was added to an interface, all the implementing classes were forced to implement it. Otherwise, the code would fail to compile. But now, with default methods, we can provide an implementation directly inside the interface without breaking the existing code. If a child class wants to override the method and give its own implementation, it can do so. If not, the default method implementation defined in the interface will be used automatically. This means no changes are required in the existing implementing classes. Alright, so let me show you. I have an interface named payment, and it has this method void pay. Alright, so this is an abstract method which has no implementation. Okay, so we have 3 child classes of this interface: credit card, net banking and UPI. And in all these classes, this method has been implemented. Okay, they have given their each implementation. Okay, in net banking, similarly in UPI as well. Okay, so far everything seems fine. But let's say I want to add one more functionality. Let's say now I want to add a refund functionality. Okay, so I just add another method, void refund. Okay, so what happens is that it has created a certain problems. Okay, if I'll go inside this implementation, you can see that there is a compilation error that says class credit card must either be declared abstract or implement the abstract method refund. Okay, so it's asking this class to implement this method. Okay, this one, the refund that we just added. Similarly, UPI will also have to implement it, and net banking will also have to implement it. Okay, so first of all, why do they have to implement this method? Because let's say I just create an object of net banking and I try to call this method refund. So what exactly will be called? There is no implementation right now. Correct. So that is why compiler will not know what exactly to call. So that's why there is a need for some implementation. Okay. So now what is the solution for this? I can simply just implement this method. Let's say I just implement refund. I can give some print statement. Similarly, in net banking as well, I can implement this method. All right. And in UPI also, we'll just implement the method. Okay. So that is one way. But the problem is, let's say there is an interface with hundreds of implementations and you just want to add some functionalities. So all the implementations will have to implement that method. Okay. So before adding that functionality, you will have to give all that logic. Okay. So now that is not backward compatible and that is a bit tedious. So to solve this problem, what Java did was, let me first just remove this. Okay. We will not give implementation here. All right. Okay, so here we have not given in UPI and in net banking also. I will remove it. Yeah. So instead of giving the implementations there, what we can do, simply we can make this method as default and we can provide our own implementation. Okay. So now you can see that there is no issue in any of these classes, because now if we create an object of credit card and we try to call this payment, this refund method, so this default implementation will be called. Okay, so as of now I have not written anything. I can write something as well. Let's say default refund flow executed. All right, something like this. Okay, so this makes the code backward compatible, and now we can just add any of the methods that we want to without breaking the existing code. Okay, if these classes want to give some of their own implementation for refund, they are allowed to do that. They can just override this method and give their own implementation. If they don't want to, then there is no necessity for them to do it. Okay, the code will not break. All right, and also, like, I'll give one more example. Let's consider this list.java. Okay, so this is a class which is of this package java.util. So this class belongs to Java itself, and actually they were also facing the same problem. They wanted to add some functionalities in this interface list, but you can see that list has so many implementations. There are a lot of implementations and Java is used worldwide, so everyone have to implement it. Okay, so that's why they introduced default methods. So I'll show you some examples, like default. Here we have this default method split iterator, or we have this sort method. Okay, and we have the replace all. So all these methods were added with a default keyword so that the existing code would not break. Okay, so the answer is that this default method was introduced, this default keyword was introduced for backward compatibility. Now there are certain rules associated with default methods. So let's look at them one by one. First rule says that we can have multiple default methods inside an interface. Okay, so let's say I want to create one more default method. Let's say something is valid payment. Okay, something like this. And I just want to give an implementation here as well. So I can also create a default. I can use a default keyword and create method like this. Okay, let's say I'm just simply returning true for now. Okay, so in the same interface, we have multiple default methods. Now, second rule says that these default methods can be overridden as well. Okay, so as I told you, if these child classes want to give their own implementation, they can do that. Okay, so I will just implement it. Let's say I want to implement refund. Okay, so here this class has its own implementation. It says cc refund flow executed. All right, now in the main class, if I just create an object of credit card, let's say obj1 is equal to new credit card, and using this object, if I call refund, okay, and I create one more, let's say for UPI, obj2 is equal to new UPI, and using UPI also I will call, okay, using this object also I will call the refund method. Okay, so in credit card I have given some implementation, in UPI I have not implemented refund, okay, I have not overridden it. All right, so if we run this, great. So for this credit card the CC refund flow executed, but for UPI the default refund flow executed. All right, now there is one more issue. There is actually an issue with this default keyword as well. Let me tell you about that. So it is called multiple inheritance problem, or we also call it as a diamond problem. Okay, so I'll take one more example. Let's say I have a calculator interface. Here we have a simple method int operate. Okay, it takes two arguments, int a comma int b. All right, so we have this calculator interface, and let's say this is a default method. I simply give an implementation where I'm returning a plus b. Okay, so I'm returning the sum of these two values, and let's say there is one more interface, calculator1. Okay, let's say it's an interface, and here as well we create this default method operate. It also has the same name, but the implementation is different. Okay, here we are multiplying the two fields. All right, now there is a child class, right? Let's say child calculator, or let me call it a simple calculator IMPL, calculator implementation. Okay, and this implements calculator as well as calculator1. Okay, so this child class implements both these calculators. So now there is an issue, there is a diamond problem. How? When I'll create an object of this class calculator IMPL, now compiler will again won't know which method to be called. If I try to call this operate method, this implementation is implementing both the calculators, so the compiler will not know which operate to be called. Okay, so the rule says that whenever a child class is implementing multiple interfaces and those interfaces have the same method with the same name, so in that case it has to implement that default method. So okay, so now it's a necessity for calculator IMPL to implement this method, and here we have to tell which one we want to actually call. Okay, so using calculator.super.operate, we are saying, we are actually telling compiler that the operate of this calculator interface has to be called. Okay, so let me show you in the main. Let me just remove all this. We have calculator implementation, C is equal to new calculator implementation. Using this, if I call the operate method 10,20 and I simply run it. Okay, we have not printed this, so system.out.println, just print the result. Okay, so you will see that these two values have been added because we have written calculator.super.operate. So this one will be called. Now instead of this, if I write calculator1.super.operate and then I run it, so now it will be a multiplication because this method was called, the one present in interface calculator1. Okay, so this rule was that whenever a class is implementing multiple interfaces and those interfaces have a method with the same name, then the child class will have to give some implementation of its own. Okay, now let's consider one more scenario. Let's say this calculator1 was not an interface, it was just a class. Okay, and I'll not create a default method here. This will be a normal public int operate. Okay, so this is a class calculator which has this operate method, and calculator is an interface which also has operate method, but this one is a default one. Okay, so this calculator IMPL, now since this is not an interface, so we will just extend calculator1 and implement calculator interface. Okay, and let me remove this. All right, So now the child class is extending one class and it is implementing an interface. And both the interface as well as this class have the same method. Okay, method with the same name, but they have some different implementations. Okay, so now if I try to call this method operate using the implementations object, okay, so what will be called? Whether it will be this interfaces method or will it be this classes method? Okay, this one, sorry, calculator one, this classes method or this interfaces method. Okay, so let's see if I run my application. Great. So you will see that multiplication has been performed, which means that the method of this class calculator 1 was called. Okay, so this is rule number 4. It says that whenever a child class is implementing one interface and extending another class, so the class will get precedence in case there are two methods with the same name. Okay, so this class will get precedence, which in this case is calculator 1, and this interface will be at the priority 2. All right. Now there is one more rule, a last rule that I want to tell you, and mostly people miss this, that we have a class object, okay, which is the parent class of all the classes. All right, and you can see it has some methods, like it has a method equals. Okay, I'll show you. Okay, there is this method equals. So let's say I just take this method and this is my interface. Here, let's say I just try to override this method. Okay, I'll give some other implementation and I'll add a default keyword. Okay, simply return false. All right, so this I cannot do. All right, in any other class I can override the method of object class, because object class is the parent class of all the classes. So in any other class I can override that method and give my own implementation, but I cannot do that in an interface where I'm using the default keyword. Okay, so you can see that it gives me an error that says default method equal overrides a member of object. All right, so this is one more rule which you must keep in mind, that you cannot override a method of object class and give the default keyword, okay, in this interface. All right. Hello and welcome to my channel, The Curious Coder. Today I'll be talking about another very interesting feature that was introduced in Java 8, static methods inside interfaces. Before Java 8, interfaces were very strict. We were not allowed to add static method inside an interface, but starting from Java 8, Java allowed us to do so. Now the question is, why was this needed? Think about it. Sometimes we want a method that logically belongs only to the interface. We do not want child classes to override it and have their own implementation. It could be a helper method or some validation method. But the point is that we want that behavior to stay with the interface itself, not with the implementing class. That is exactly where static methods come into the picture. Let's move to IntelliJ and I'll help you understand how this actually works. So I have taken an interface named payment. As of now, it has two methods, pay and refund. And I've taken three child classes, UPI, credit card, and net banking. And you can see that all these child classes have their own implementations for pay and refund. You can see that every child class have their own implementation. All right. Now let's say I want to add some validation inside this interface. I want to create a method, boolean is valid amount. Okay, I'm validating the amount like this, int amount. And my logic for validation is that if the amount is greater than 0, then return true. Okay, it's a valid amount. Otherwise, simply return false. All right. So this is a logic for validation that I want to add inside my interface. And I want this logic to be common for all the child classes. Okay. So I don't want any child class to override this method and give their own implementation, because it's just a simple validation logic. So I want it common for all the classes. Okay. So how can I do that? Now before Java 8, this was not possible because we could only declare some abstract methods which the child classes can change. But after Java 8, we can do it using the static keyword. Okay, so this is how we can declare static methods inside our interface, and these static methods belong only to the interface, not to the child classes. Okay, these methods are not a part of child classes, and I can show it to you. Let's say I create an object of credit card, and using this object I can call the pay method, I can call the refund method, but if I try to call is valid amount, this I am not able to do, because it says static method may only be called on its containing interface. Alright, let's say if I try to call it directly using the class name, that also I won't be able to do. Okay, again it will give me the same error. Alright, so this proves that the static method belongs only to the interface. Now let's say I want to override this method. Okay, I want to override this is valid amount inside net banking and give a different implementation. Alright, so let's try that. We have public boolean is default, is valid amount. Okay, and there is int amount. Okay, so let's say I just simply return true. Alright, so you won't see any compilation issue here, but if you look at it carefully, this is not an implementation of is valid amount. This is not overriding, because when we override a method like we did here, we get this sign that says that we have overridden a method of this interface payment, and here is the implementation. Okay, but in this case, what we simply did was we just created a separate method here. Okay, so this is a totally separate method that belongs to this class net banking, but this is not an implementation of this method. Alright, so this is actually called method hiding. This is not method overriding. Alright, so far we have seen that a static method belongs to the interface and a static method cannot be overridden. Okay, so I'll just simply remove it from the implementation. Okay, we have it here in net banking. Alright, so this is just method hiding. Okay, now there are certain other features about this static method. One is that we can create more than one static method inside an interface. So let's say I just simply create some method log time. Okay, let's say I want to log the time. Okay, so we simply print term.out.println new date. Alright, something like this. So that can also be done. Inside one interface, we can have multiple static methods. Also, one static method can call another static method. Okay, so let's say from this method, I want to call the log time. That is also possible. Okay, there is no issue in that. But if I want to call a default method, simply I just create another method, a default method. Okay, and if I try to call it from a static method, that actually I cannot do. Okay, so that is a characteristic of this static method, that it does not allow us to call a default method from a static method. Okay, and there is one more thing. The static methods that we create, we always have to define a body for those methods. We cannot leave them abstract. Okay, so if I just simply keep it like this, I remove the implementation and I try to create it abstract, that I cannot do. And actually that makes sense, because since no child class can override it and give its own implementation, so that is why it is necessary for us to provide the implementation here itself in the interface. Right, that is only logical. Okay, so always a static method has to be given some implementation. Alright, now one more thing. If a static method cannot be implemented inside a child class and it cannot be even called by a child class, then how are we gonna invoke this method? Okay, who will call this? So let's see. First, let me give some implementation here. System.out.println new date. Okay, so in the main class, we have already seen that when I created an object of credit card, I was not able to call my method using that. Okay, So actually it's very simple. We just take the interface name and using this, we can directly call our method. Okay, like this. Let me just print it. System.out.println. All right. Great. So you will see that the static methods are invoked. Okay. Now this is a summary of all the features of static methods inside an interface. I have created it so that you can take a screenshot of it. It will be very helpful for you when you want to revise this topic. Alright. Hello and welcome to my channel, The Curious Coder. In this video, we'll be learning about one of the most important feature that Java 8 introduced, functional interface. What is a functional interface? It is an interface that contains exactly one abstract method, which makes it suitable for Lambda expressions. Alright, so it's an interface that contains exactly one method which is abstract, not more, not less. Why? Because that makes it suitable for Lambda expressions. Now what are Lambda expressions? That we'll understand just in a while. For now, let's try to create a functional interface. So what I'm gonna do is, I'll just simply create an interface. Let's say my interface. Now, is this a functional interface? No, not yet, because as of now, it does not have any abstract method, but we need one abstract method. All right, so let me add a method. Let's say void method 1. All right, so now is it a functional interface? Yes, now it is, because it has only one abstract method. Okay, so I hope you guys know what abstract methods are. Basically, these are the methods that we just declare. They don't have any body. Okay, they don't have any body like this. So these are called abstract methods. All right, so this can be considered as a functional interface. Now let's say I add one more method, void method 2, like this. So now is this a functional interface? No, again, this is not a functional interface because it has two abstract methods and we only need one. Okay, but let's say I make it a default method like this. All right, so default methods have body inside them. Okay, we can add curly braces and give any body if we want. So now is this a functional interface? Yes, it is still a functional interface because the only rule is that there should be one abstract method, but we can have as many default methods as we want. Okay, similarly, we can have static methods inside a functional interface. Okay, so let's say we have a method 3 like this. So still this can be considered as a functional interface. All right. Also, there is one more thing. It is recommended that we should put this annotation @functional interface on a functional interface. Okay. So what is the role of this? It basically restricts the interface to behave as a functional interface. All right. What do I mean by that? Let's say now if I add one more method, okay, like this, void method 4. So I have added one more abstract method. So you'll see that it is giving me some compilation issue. It says multiple non-overriding abstract methods found in my interface. All right. So this means that this annotation has added a restriction on this interface that it should not break the rules of functional interface. And as I told you, functional interface can only have one abstract method. So that's why it's giving me a compilation issue, because here we have created two. Okay, so I'll just remove this and now it works fine. Similarly, if I'll just comment this one, again it will give me it will give me an error that says no target method found, because we still need one method. Okay, so this is what functional interface is. All right, these are all the rules and this is how we can create any functional interface. Okay, now what's the purpose of it? Why does it have this rule that it should have only one method, and what exactly we are going to do with this interface? So actually the main purpose behind this is that we can give an implementation of this interface using Lambda expressions. All right, so now let's understand what Lambda expressions are. Lambda expressions are a concise way to represent an implementation of a functional interface using a short readable syntax. Basically, they are designed to reduce a lot of boilerplate code. All right, so they implement the functional interface and in a very short manner, okay, using very less syntax. All right, so let's see how they do that. So I have created an interface named vehicle and I've declared it as a functional interface and it has this abstract method start. Okay. Now let's say I want to call this method. Okay. So can I just create an object of vehicle like this, and using this can I call it? Okay, we have vehicle v1 is equal to new vehicle, and using this I want to call this method. Okay, so it gives me some compilation issue that says vehicle is abstract, cannot be instantiated. Okay, so there is a problem with this, and the problem is that we are actually not allowed to create objects of interfaces. Okay, now why can't we do that? Because see, logically the start method does not have any implementation. There is no body of the start method. So if you'll create an object of vehicle and if you are going to call this method, then what exactly should be called? Right? Because we don't have any body, we don't have any implementation. Okay, so the compiler won't know what exactly to trigger. Okay, so what's the solution? So the solution is that we can create a child class to implement this vehicle. Okay, so let's say I have a class named car that implements vehicle. Okay, and here we will have to implement this method. Right, so this car class will override this method vehicle and give some implementation. Okay, so let's say I'll say system.out.print. I will say car engine started. All right, so now we have an implementation for this method. Okay, but still if I'm trying to call it using the vehicle object, it still gives me an error. Now what's the problem? So the problem is that even if we create an implementation, but still we cannot call it using the vehicles object, because the thing is that what if I create more implementations? Okay, let's say I have another class bike which also implements vehicle. Okay, and here let's say I give a different implementation. Okay, I'll just say bike engine started. All right, so now how would the compiler know that when we are calling it using a vehicle object, which of these two implementations should the compiler call? Okay, we have not specified that. That is why we cannot create an object like this. Okay, so what was the solution? Solution was that we should create an object directly of the child class. Okay, so the child class, one of the child class is car. So I'll create an object of car and put it in a reference of vehicle. And using this, I can call the start method. Similarly, I can also do the same for bike. Okay, I can create an object of bike, and using this I can also call the start method. Okay, so if I run it, great, you will see that this printed car engine started and this one printed bike engine started. All right, now this is how things were done before Java 8. Now you might observe that whatever we did so far is actually containing a lot of redundant code. Okay, there is a lot of boilerplate code that we actually don't need. Why? Because you see, we have this start method, and at the end of the day, we only want to implement it. But just to do that, we are creating two child classes and then we are calling methods using those objects. Okay, so I think there is a scope of reducing this code. All right, so what can I do? I can just, let me just first comment this out. Okay, and 1 second, I'll just copy paste this. I'll copy this, paste it over here. Okay, so I'll comment this part. This was one way of doing things. Now we'll look at the second method. Okay, so at the end of the day, all I need is I need some implementation here. Okay, so instead of giving it like this, like writing it like this, new car, I'll just simply write new vehicle. Okay, and if somehow I provide an implementation here itself instead of creating this class, then my job is done. Okay, so how can I do that? I'll just simply click here, implement methods, and this is how I will provide an implementation here itself. Okay, this is called anonymous inner class. All right, so we didn't need a separate car class. We can provide an anonymous implementation here itself, and here I can just simply say system.out.println. Let's say I want to give an implementation of car only, so I say car engine started. Okay, so now I won't be needing this class car. Okay, I can delete it. Okay, and using this v1, now I can call v1.start. All right, so we didn't create an object of class car. We created an object of vehicle only, The only thing which was missing is the implementation that we provided here itself. Alright, similarly, I'll do the same for bike. I can just say vehicle and here I will implement. Okay, so system.out.println, let's say bike engine started. Alright, so v1.start, v2.start. Let me just call this. Great. So again, using anonymous inner classes, we can implement this method. Okay, and now I'll also delete the class bike. Okay, so now what lambda expressions do is that they are actually one step further. Okay, they reduce this code even more. That is what lambda expression is. It is nothing fancy. It is just a way to give implementation of a method. Alright, inside a functional interface. Okay, so let me just copy this also and I'll comment this part. This was the first way. This is the second way of doing things. Now I'll show you the third way. Okay, so see, the catch here is that this vehicle interface contains only one abstract method because it's a functional interface. Alright, that we know, and actually that compiler also knows. Alright, so that is why, since it's only one method, so do we really need to provide all this name over here that we are implementing this method start? We don't need to tell the compiler again. It already knows that this interface has method start. So whichever implementation I'm giving here will obviously of the method start. Okay, so I don't need this code, so I won't be needing this. And actually I already know that it's a vehicle reference, so I don't even need to write this. Okay, so I'll just remove this as well. Alright, that's it. This is the implementation, and when I'm giving it like this, I have to add a hyphen and then an arrow. This is what lambda represents. This is called lambda, and this is my final syntax. Alright, very simple. It reduces the code to a very large extent. You'll see that we have given these parentheses, then a lambda, and here I'm giving the implementation. So this actually represents this only. Okay, the way we gave an implementation here, similarly I can write it in a short way like this, and this is what called a lambda expression. And you will see that in this method implementation we are only writing one statement, a single statement. So in that case I don't even need these inside braces. Okay, so I'll just remove this and I'll remove one semicolon and I'll remove this. Alright, so this is how I can implement using lambda. Similarly, I'll do it again. I'll show it to you. First, we remove this method name and override. We remove this parenthesis. We don't need to tell the compiler that it's a vehicle object because we have the vehicle reference. Okay, so we remove this. Here, I will add a hyphen, then an arrow, and this is the implementation. Now, this implementation has only one line, so I don't even need this, and I don't need this, and I don't need this. Okay, simple. This is how I will give my implementation. Alright, so you will see that we have done all this only in just a single line. Okay, now again I want to tell you what it actually represents. This line here represents the implementation of the start method. Okay, so whatever the start method, whatever implementation, whatever body you want to provide to the start method, that is written here after the lambda. Okay, similarly here in v2, and I'll run it again. Great. So again, car engine started and bike engine started. Okay, so the first way is that you create a child class, and using the object of that class you call the method. The second way is that you provide an implementation using an anonymous inner class, and the third way is that you do it using a lambda function, okay, lambda expression. So this is just a different type of syntax, nothing else. It's very short, and it only works because vehicle has one abstract method. Alright, if it would have had multiple abstract methods, then we could not do it like this, because then the compiler won't know that which method we are talking about, because then we will have to name the method like we named it here. Okay, but since there is only one abstract method, so that's why we can give an implementation like this. Alright, now I think that this topic is a little hard to understand, especially in the beginning. So to understand it, there is only one way, that we should practice it a lot. And that's why in my video, I'll be taking multiple examples. I've created 4 different functional interfaces, and one by one, I'll be implementing all these interfaces. But still my recommendation is that you should practice it on your own as well. Okay. create some functional interfaces, do some implementations of it, read some examples, and eventually you'll get a hold of it. Alright, but in my video as well, I'll cover a lot of examples and I hope that it will be very helpful. Okay, so this is the first interface. This is an interface named greeting and it has this abstract method. Okay, so I'll implement it the same way I've implemented the vehicle interface. Okay, now the trick is that always first write the interface name. Alright, because see, every time you won't do it like this. You won't be creating a child class first, then you will be creating an anonymous class and then breaking down that code. Okay, you should directly write a Lambda function. Okay, at some point you should know how to write it directly. Okay, so I'll just tell you the trick for that. So first write the interface name, then give your object some name. Let's say I say G1, and after that just check how many arguments does this method have. So as of now it does not have any argument. So simply just add a parenthesis, add the lambda, the hyphen and an arrow, and always make it an habit, always give these curly braces in the beginning. Okay, always first give these curly braces and a semicolon. Write it like this. Now this is the area where you're gonna give your implementation. Okay, this is where this method greet will be implemented. Alright, so let's say I simply write a statement system.out.print hello everyone. Okay, a simple print statement, and that's it. You have given an implementation for the greet method. Now after that, check that whether this implementation is a single line implementation. Yes, in this case it is a single line. We are only printing something. So in that case, you can remove this, you can remove this, and you can remove this semicolon. Okay, so this is the whole implementation. Alright, now using this G1, you can call the greet method. Alright, now similarly, let's take one more example. We have an interface named task and the method is execute. Okay, so this time again I'll take task. Let's say I name the object T1 is equal to, in this task, again we don't have any argument, so I'll simply take a parenthesis, then a lambda, and again initially I will add these curly braces and a semicolon. Now let's say I want to write two statements here. Okay, first is that task started, then something like, let's say task ended. Okay, simple. So in this case I cannot remove these braces. Okay, if I want both these statements to be a part of the implementation of this execute, then I will have to write both these statements inside the curly braces. Alright, that's the rule. So this is how you implement a multi-line implementation. You give a multi-line implementation, but in case of a single line, you can remove these braces as well as this semicolon. Okay, so again using this T1, I can call T1.execute. Alright, cool. Now coming to the third example. This is an interface square, and let me just also add this annotation. Okay, even though if I didn't add it, it would have worked because there is only a single method, but I still it's recommended, so I like to add it. Alright, so we have this interface, it has this method operate. Now this time the return type is int and we are also taking an argument. Alright, now that is an interesting example. So first always write the interface name. Let's say square s1 is equal to, this time we have an argument. Okay, we have one argument. So here I will take an argument. Alright, like this number, and I'll write the lambda and then the curly braces. Okay, so we will have to take an argument because here in the method square we have this argument. Okay, now this number, using this number I'm saying return number x number. Okay, I'm returning the square and put a semicolon here as well. Alright, so now this is the implementation. Okay, so is there any scope of reducing this further? Actually, yes, there is. First, let me just clarify one more point. I'll reduce it as well, but let me just clarify one more point. So the thing is, when you see the code like this, many people get confused. But the thing is that since we are returning something here, let's say the number is 10. Okay, so we are returning something here. So people think that the value 100, that will be returned and will be saved in this object. But that is not true. the return type, the returning thing is of this method, which is this square, which is this operate. Okay, so when you are actually calling the operate method, at that point of time, this code will be triggered. Okay, so whatever you are returning here, that is not getting returned here in S1, that will be returned here. I'll just print it, system.out.println. Okay, so when you actually call the method, at that point of time, this implementation will be called. Alright, this is how it is working. Imagine it like this. At this point, you have only given the implementation. You have not actually triggered any code, because the method is actually getting hit at this point of time when you are actually calling the operate method. Alright, so just please think of it like this. I wanted to make it clear. Okay, anyways, so in the operate method, here I will pass the value, which is 10. This value, this 10 will be passed on here, and it will actually return 10 into 10, so 100. Okay, so this will be returned here in the print statement. Alright, now okay, can I further optimize it? Yes. How? First, this also has only one line, correct? So I can remove this, I can remove this, and I can remove this. Alright, now there is one rule. If inside this single line there is a return statement and you remove the curly braces, then you also have to remove this return. Okay, compiler already knows that you are returning something. So the implementation will be like this. There is a number and you are returning a square of number. Now this is just an implementation. This will actually be triggered when you will call the operate method, which is here. Okay, and there is one more optimization. If there is a single parameter, in that case, you are also allowed to remove these parentheses. Okay, so please remember that if there is a single parameter, you can also remove this parenthesis. So we will just write number and return number into number. Alright, great. Let me just run it so far so that you can see. Okay, so when g1.greet was called, this statement was triggered and hello everyone was printed. When t1.execute was called, these two statements were triggered and task started, task ended was printed. Similarly, when s1.operate was called, then only this square was returned in this from this operate method, and whatever value was returned, we are printing it. That's why 100 was printed. Okay, cool. Now let me take one more example. This time we have two arguments. Okay, and we are returning some int value. Alright, so I'll take this example. I'll write the interface name, calculator, give object some name, let's say C1 is equal to, since there are two arguments, so I will have to take it like this, let's say a comma b. Okay, you can name anything, you can name the argument anything. Like here it's num1 and num2, but here you can say a comma b as well. There is no issue in that. Alright, now a hyphen and an arrow representing lambda, then these parentheses and this semicolon. Okay, so I could just directly return a plus b, but let's say I am taking it like this, int result is equal to a plus b, and I am also printing it system.out.println, let's say result, okay, which is this result, and then I am also returning this result. Alright, like this. So this implementation is not a single line implementation. That's why I should not remove these curly braces. And has this code been called yet? No, because as of now we have only provided the implementation which is there in the C1. But when I'll call it using C1, C1.add, let's say 10,20, at this point of time this code will be triggered. Okay, and since I have this print statement here only, so I will not print it again. Let me just show you. Great, so this statement got triggered, result is 30. Okay, the sum of a and b. So you passed 10 and 20 in this add method. So these were 10 was equal to a, 20 was equal to b. These were saved here in the result, and then it was printed here and also returned back. So where is it returned? It will be returned here. Okay, I can add it here as well. Int final result, something like this, is equal to c1.add. If I'll print this, this will also be equal to 30. Alright, hello and welcome to my channel, The Curious Coder. This video is part of my Java 8 series, where we are exploring the most important Java 8 concepts that every developer should know, especially for interviews and real-world development. In today's video, we are going to understand 4 very important functional interfaces predicate, consumer, function, and supplier. These interfaces are heavily used with Lambda expressions and Streams API, and once you understand them properly, a lot of modern Java code will start making much more sense. Let's start with predicate. Predicate is a predefined functional interface that takes one argument and returns a Boolean value. It is mainly used for conditional testing. Alright, so this is the interface predicate. As you can see, it is a functional interface. It is predefined inside this package and it contains this abstract method named test. Alright, so this test takes only one argument and it returns a Boolean value. Okay, and this argument can be of any data type, whatever is passed here in the generics. Alright, so we have this flexibility that we can pass any data type inside this generics and the argument will be of the same data type. Okay, so let's see how we can implement it. The rules are same. First we'll write the interface name like this. And let's say in the generics, I want my argument to be of the type integer. Okay, I'll give it some name. Let's say p1 is equal to. Now since this method takes one argument, so here also I will have to take one argument. Okay, so I can name it anything. Let's say I name it num. Okay, representing some number. Alright, after that I'll put an arrow and you'll see that IntelliJ has already shown that it is of the type integer because here in the generics we passed it as integer and whatever we pass here will be the data type of the argument. Okay, and here in the parenthesis this is the argument that we are taking. Alright, so this is the number and let's say I want to give first let me add these braces and semicolon like this, and here I will give the implementation of this method test. Okay, I'll give some implementation. So let's say I want to check whether this number whatever we are passing is even or not. Okay, so I can simply give a condition if num mod 2 okay like this is equal to 0, then we should return true. Alright, else we can return false. Okay, so this is the implementation of this method test. Okay, it is taking one argument number and we are saying if the number is even then return true, otherwise return false. Okay, so we are checking some condition that whether a number is even or not. Okay, now this is just an implementation. This method will actually be called when I'll call it like this p1.test, and here I'll actually pass some value inside the argument. So let's say I'm testing 10 and I'm testing 7. Okay, p1.test 7. Alright, so let me also print the result system.out.print. Similarly here as well. Alright, okay, yeah. So if I run my code, great. You will see that this returns true because 10 was an even number and this returns false. Okay, so this is how we can implement predicate interface. We can give an implementation for this method test and it will take some argument and it will return some Boolean value. Okay, now I'll take one more example. This time I'll take some string argument, predicate string, and let me call it p2 is equal to. This time also I have to take one argument. Let's say I'm calling it some str, then this arrow and these parentheses, these curly braces. Here I will provide the implementation. So I'm trying to say if string is empty, if the string is empty, then return true. Okay, else return false. Okay, this is the implementation. So here in this condition I'm checking whether or not the string is empty. Okay, now using this p2 as well, I will call the method p2.test, and inside this test I can pass an empty string and also I can pass some non-empty string. Okay, let's say my name. Alright, I'll simply print this system.out.println p2.test. Similarly, system.out.println this one. Okay, So if I run my application, great, we got true, false, then true, false. So true for this, false for this. Now since it's an empty string, so it returns true and then it returns false. Alright, so this is how predicate works. Now I also want to tell you that we can optimize this a little bit more. Like we have written a lot of lines here. We could have simply written it like this: return str dot is empty. Okay, we could have directly written this. Similarly here as well, I could have written return num mod 2 is equal to 0. Okay, I can directly write it like this. Now there is one thing in this functional interface and Lambda expression, that when the implementation you are giving is of a single line, like here you can see it's just a single line. In that case, you can remove this, you can remove this, and you can remove this semicolon as well. Okay, it will be simply written like this, and you can also remove this return keyword. Okay, so actually you'll write it simply like this. So you're saying num and then arrow and then num mod 2 equal to 0. You'll directly give the condition. Similarly here as well, I will remove this and remove this. Okay, and return statement as well. So I'm able to do this because the statement is of single line. Okay, we are not doing anything else. Alright, so this is all about predicate. Now let's understand function. Function is a predefined functional interface that takes one input and returns some output. It is basically used for transforming the data. Alright, so this is the interface function. As you can see, it is also a functional interface and it has this abstract method named apply. Okay, now here as well, we can take one argument, but unlike predicate, the return type is not fixed as Boolean. Okay, instead we can take any return type and we can pass it here in the generics. Alright, so it has the flexibility of passing the data type for the argument as well as for the return type. Okay, so let's see some examples. I'll just write the interface name. Now let's say I have some string value and I want to return the length of that string. Okay, so I'll take the argument type as string, and since I want to return the length, so I'll take the return type as integer. Okay, then I can give some name to the object. Now here as well, we have only one argument, so I'll take a single argument like this, str, then arrow and curly braces. Okay, now whatever I provide here will be the implementation of this method apply. Okay, so I want to return str.length. Okay, simple. Now using this F1, I can call apply. Let's say the string is Shivam. Okay, so I'm passing a string value and I want to return its length. Okay, so whatever is returned will be printed here. Okay, I'll just print this. Alright. Okay, so let me run the project. First, let me just comment these out. Okay, we have already seen predicate. Cool. So if I run the application, great. So the length of this string is printed, which is 6. Okay. Now again, here we have a scope of optimization. Since it's a single line, I could just remove this, and this semicolon as well. And we also don't need this return keyword. Okay. So simply we can write it like this. Alright. Now I'll take one more example. Let's say I have some number, I have some value, and I want to return the square of that value. Okay, so I'll take another function and I have some integer value and I want to return some integer value only. Okay, I want to return a square root, not a square root, a square. Okay, let me call it F2, and we have some number. I'll first write it like this only. Okay, and I want to return number into number. Okay, now using this F2, I will call F2.apply and I'll pass 10. Alright, so this is the number that I passed, which will be this one, and in the return, basically in this implementation, I want to return the square. Okay, now again this is a single line, so I'll remove this, and I'll also remove the return keyword. Okay, so simply I'll write it like this. Alright, now let me run my application again. Okay, I have not printed this. Let me print it. Great. So you can see that we passed 10 and 100 was returned. Okay, so this is why we use function. It is mainly used to transform data, and whenever we want to map one data into another, we can use function. Now what is consumer? Consumer is a predefined functional interface that takes one input but returns nothing. It is mainly used to perform any operation where you don't need to return anything. Alright, so this is the consumer interface. As you can see, it takes one argument but it has no return type. Okay, so this is the abstract method accept that takes one argument but there is no return type. Alright, so let me show you some examples. Let's say I just simply create consumer and I want to have some string argument. Okay, so I will take some argument. Let's say the argument is name. Okay, I'm giving it its name is name, and simply I want to print this name. Okay, I don't want to return anything. I simply want to print my name is name. Okay, like this. Alright, so this is what consumer is used for. I took some argument but I didn't want to return anything. Okay, then using this I will just call c1.accept and I will print the name. Okay, like this. Alright, now again this is a single line implementation, so I'll remove this and simply write it like this. Okay, similarly I can also take a different argument. I could have taken integer. Okay, c2 is equal to, and I could have taken my age like this, and I can again simply print it. Okay, this time I'll not take the curly braces, I'll give a single line implementation. Let's say I'm saying my age is something. Okay, so my age is age. Okay, and here I will pass it c2.accept 28. Okay, like this. Alright, I'll just run it. Great. So both these statements are printed. Okay, when c1.accept is called, this statement will be printed. Shivam will be passed as argument over here, and here it will be printed. Similarly, when c2.accept is called, this number is passed as a value here and this is printed here. Okay, so nothing is returned from this. Okay, there is no return type when you call these two methods. Alright, now at last we have supplier. Supplier is a predefined functional interface that does not take any input but returns some value. It is mainly used when you want to generate or supply data. Alright, so this is the supplier interface. As you can see, it has this method get, but it does not take any argument. However, it returns some value. Okay, so it is kind of opposite to consumer. Consumer takes value but does not have a return type. However, supplier does not take any value and has some return type. Okay, so let me implement this. First, I'll just comment this out. Okay, so supplier, let's say I want to return some integer value. Okay, so like this, I'll just call it. Now since it does not have any argument, so I'll leave the parenthesis like this and arrow. Let's say I want to return some random number. Okay, I'm just simply calling, I simply say return math.random. Okay, like this. Now this returns double, so I'll just cast it to int. Okay, like this. Alright, now using this I will call s1.get. Okay, and we will just print the output. System.out.print. Alright, so we didn't take any argument, but this implementation returned some random number. Okay, let me call it. Great, so it returns 0. If I'll call it again. Okay, so random number is again and again printing 0 only. Alright, now I can take one more example. Let's say this time I want to return some string value. So let's call it s2. Okay, and I have a string as string a is equal to, let's say, Shivam. String b is equal to Gupta, and I want to return a concatenated result. Okay, a dot concat B. Alright. So this supplier takes no argument. Inside the implementation, there are two string values and we are returning a concatenated result. Okay. So when I'll call the method s2.get, this value will be returned. Okay. Simply just print this system.out.print s2.get. Okay. I'll run it again. Great. So the concatenated string value is returned. Alright. Also here I could have removed these braces and this return as well. Okay. We can simply write it like this. But here I cannot do this because this is not a single line implementation. Alright. So these were 4 interfaces that are used very widely in Java 8. And actually when we'll study about streams as well, there we'll see the use cases of these. Okay, so stream has many methods where we use these directly. Alright. Hello and welcome to my channel, The Curious Coder. This video is part of my ongoing Java 8 series. Today, I'll be talking about a very important but a little tricky topic, method reference. So what exactly is a method reference? Simply put, it's a shorter way to implement a functional interface. But wait, doesn't Lambda do the same thing? Yes, it does. However, at times, we can make the syntax even more optimized using method references. I know it sounds a bit confusing in the beginning. That's why in this video, I'll explain it in the simplest way possible, and the video will be full of examples to help you understand it easily. Okay, so let's get started. So I have created a functional interface named calculator. Now what is a functional interface? Any interface that contains exactly one abstract method is called a functional interface. Alright, so this interface contains only one abstract method named calculate. That is why this can be considered as a functional interface. Okay, now we can implement this method calculate in a very short way using Lambda expressions. And sometimes we can make it even shorter using method reference. Okay, so let me show you. Let's first see how we can do it using Lambda expressions. Okay, so the syntax is very simple. First, we need to write the interface name like this. Then we'll give some name to the object. Okay, then since in this method there are 2 arguments, so here as well I will have to take 2 arguments. Okay, like this. After that we use the lambda operator, this arrow operator. Okay, and after these we put some curly braces. Okay, we put these curly braces and end with a semicolon. Alright, now whatever you write between these 2 curly braces, whatever you write here actually represents the implementation of this method calculate. Okay, so let's say I just want to add these 2. Okay, so I'll say return a plus b. Okay, like this. So this part is actually the implementation of this method calculate. Okay, so if I run this code, does anything happen? Let me see. Alright, so as of now nothing will happen because we have only declared the implementation. We have not actually called this method calculate. Okay, this has not been triggered yet. So for that we have this object c1, and using this c1 we can call this calculate method, and here I can pass some values. Okay, so as you can see I passed 10 and 20. So this 10 will be passed on over here and 20 inside b, and the result will be a plus b, which we'll get here. Okay, because here is where we are actually calling the method. Alright, so I'll print the result. Alright, great. So you can see that the sum of 10 and 20 has been printed. Alright, so this is how Lambda expressions work. Now, can I make the syntax even shorter and convert it into a method reference? So actually no, I cannot convert this Lambda expression into a method reference. Why? Because method reference has 2 conditions. Number 1, that the implementation should only have a single statement. Alright, which in this case is true. You can see that inside this implementation, we only have a single statement. But there is a second condition that says that there should be some method call happening in that statement. Okay, so is a method call happening here? No, we are actually just taking 2 arguments and we are adding those. Okay, so it does not qualify for method reference. Alright, now let me change this example a little bit. What I'm gonna do is, I have this class math operations. Inside this, we have this method add. It is a static method and it takes two arguments and it returns the sum of those two values. Okay, so instead of directly just returning a plus b, I'll change the example. What I'll do, I'll just call math operations dot add, and let's say I pass a comma b. Okay, so we have changed the implementation a little bit. Now there is a single statement, and inside this statement there is a method call happening. Okay, we are calling this method add, which belongs to this class math operations. Okay, so now is it eligible for method reference? Yes, now it is actually eligible for method reference. So let me show you the syntax. What I can do is, instead of writing all this, we just have to write class name colon colon method name. I'll repeat, the syntax is class name colon colon method name. Okay, so again I'll give the interface name. Let's name this object as C2, and instead of writing all this, what I need to do is, I'll just write class name, then colon colon, and then this method name. Okay, like this, and end with a semicolon. That's it. This actually represents this much. Okay, and now using the C2, I will call the method calculate, and again I'll pass the value 10, 20. Okay, and let's just print this as well. Alright, like this. Okay, now if I'll run my application, great. So you can see that this was the implementation that was done using Lambda, and this is the implementation that is done using method reference. Okay, so the compiler automatically knows that whatever value you are passing here, like you are passing 10 and 20, that has to be populated inside this method add. Okay, so you don't need to specify the arguments here. This is the syntax. Okay, you just pass the value and compiler automatically knows that this add contains two arguments, and the first one will go inside A and the second one will go inside B. Okay, this is how you write it. So the condition is that there should be a single statement, and inside that statement there should be a method call that is happening. Okay, now there are actually 4 different types of method references: static method reference, instance method reference of a particular object, instance method reference of an arbitrary object, and constructor method reference. So one by one, let's understand each of them. First one is static method reference. It is used when we are calling a static method directly by the class, not by an object. So the syntax is class name colon colon static method name. Alright, let's look at it. So the example that I just covered here actually belongs to the static method reference, because this add was a static method inside this class math operations. Okay, and you can see that we have directly called this method using math operations. Okay, so this is a static method reference. Okay, now I'll take one more example. Let's say I have one more method inside this class, public static int multiply int a comma int b. Okay, and it returns a into b. Alright, so what I'm gonna do is, again I'll first implement using Lambda, and then we'll see how we can do it using method reference. Okay, so this is how I'm gonna do in the complete video, so that you get better clarity. And initially you should do it like this only, that first try to implement using Lambda and then convert it into a method reference. Okay, eventually if you start doing it, you might be able to do it directly as well. Okay, calculator C3 is equal to, I have to take two arguments, a comma b, then this operator, these curly braces, and here I'll give the implementation, which is return math operations dot multiply, and I'll pass a comma b. Okay, using this C3 I can call the calculate method. Let's say I'm doing 10 into 3. Okay, now if I want to convert this into a method reference, the syntax is, first let me take calculator C4, then this is the class name and this is the method name. So I'll just write math operations colon colon multiply. Okay, and it ends with a semicolon. Okay, so like this. This is how I can implement the functional interface. And now using the C4, I can call the calculate method 10, 3. Alright, so let me just comment this one and I'll run this part. Okay, I have not printed this. System.out.println. Similarly, great. So you can see that we get the result as 10 into 330 for both these cases. This is how we did using Lambda, and this is how we did using method reference. Okay. Next is instance method reference of a particular object. It is used when we are calling an instance method of some class using its object. The syntax is object name : instance method name. Alright, let's see. So I'll take another example. What I'll do is I'll create another interface named validator. It's also a functional interface and it has this method boolean validate. Okay, and here we take some number. Alright, so I want to implement this functional interface. Okay, inside the math operations, I'll add another method public boolean is positive. Okay, it takes a number and it checks whether the number is positive or not. Okay, return num is greater than 0. And you must note that this method is not a static method. Okay, these two are static methods, but this one is a simple instance method. Okay, now let's say I want to give some implementation of this validator. So first let me do it using the Lambda expression. Let me comment this part. So what's the syntax? First I'll write the interface name validator v1 is equal to, there is a single argument number like this, and here I'll give the implementation. Okay, so the implementation is I want to call this method is positive, okay, on the number. Now since it is not a static method, so if I'll try to call it like this, math operations dot is positive, okay, I won't be able to do this. Alright, because this is not a static method. That is why I will have to create an object of math operations. Okay, math operations like this. Okay, now using this object I can call this method, right? So alright, I'll do it like this, math operations dot is positive, and here I'll pass the number. Okay, simple, and I'll just return this value. Alright, then using this v1 we will call the method validate. Okay, and let's say I pass the number 10 and I pass the number, let's say -2. Okay, and we'll just print the result, system.out.println. Similarly here as well. Okay, so this is how we can implement using Lambda expression. Okay, if I run this, great, you'll see that we get true for this but false for this one because it is a negative number. Okay, now can this be converted into method reference? Alright, so this is a single line, yes, and here a method call is happening. Okay, so yes, I can convert this into a method reference, but this is not a static method reference. The difference is that we have called this method using this object. Okay, so the syntax is that I'll write the interface name, I'll give some object, and first I will have to write the object name. So instead of the class name, I'll have to write the object name, which I've taken math operation. I'll take something else so that it's a little bit confusing. Let's say like this, we call it m1. Okay, so here I will have to write m1 : and then is positive. Okay, like this. So this is the syntax. Using this I can again call v2.validate. I'll just copy paste this. Okay, instead of v1 I'll take v2. Alright, if I run it again, you'll see we get the same result, true false, then true false. Okay, so this is how we did the implementation using Lambda, and using this method reference we can perform the same action. Okay, so the syntax is object name : the method name. Okay, Next, we have instance method reference of an arbitrary object. It is used when we are calling an instance method on an object that is passed as an argument. The syntax is class name colon instance method. Alright, let's see. So again, I'll take a different example. Let's say I create an interface string operations and mark it as a function interface. Now this has a method int operate. Okay, and it takes some string parameter, let's say string str. Alright, so if I want to implement this using Lambda, what I can do, first let me just comment this out. I'll write the interface name string operations, give some name to the object s1. Now there is a single parameter, so I'll take one parameter, and between these curly braces I will have to give my implementation. Okay, implementation for this method operate. Alright, so let's say I want to return the length of the string. Okay, string dot length. Alright, so this is an int value that actually, and you'll see that this operate method also returns some int value. Okay, so I have returned string dot length. Alright, now using this s1 I can call s1 dot operate, and let's say I pass my name. Alright, and let me just print the result, whatever the result will be. Cool. So this is how I can implement using Lambda. If I run this, great, you will see that the length of this string Shivam has been printed. Okay, now can I convert this into method reference? Again, yes, because it's a single line and only a method call is taking place. Okay, so but in this case, the thing that is different is that here in this example, you can see that we had an object of math operations, and using this object, we were calling a method. Okay, but in this case, we have this argument, and using this argument, we are calling some method. Okay, that is the difference between these two types. Okay, so syntax wise, there is not much difference. In this case, the object was used object name colon the method name. In this case, again, we have class name colon the instance method name. So now what will be the class here? So this str is of the type string. So the class will be string. Okay, let me show you. String operations s2 is equal to, I have to write string colon length. Okay, like this. So here we'll have the method name, and the class name will be the data type of the argument that is being passed here. Okay, so this is a string argument, that is why we'll take string. Okay, now using this s2 we can call operate, and again I'll pass this. Alright, and let me just run it. Let me just print this. Great. Okay, so you'll see that both will return the same result. Okay, similarly, I'll take one more example. Let's say there is string operations. Okay, and instead of returning the length, I want to return hash code. Okay, so hash code is another method inside this class string. Okay, let me name this s3. Alright, so using this, I can just, let me copy paste this. Okay, s3 dot operate Shivam. Okay, this is the string, and similarly I'll do this thing using the method reference. Okay, so how can I do it? Again, the object is str, which is of the type string. So I will have to take string operations s4 is equal to, the class name is string colon hash code. So this time the method name is hash code. Okay, like this. Using this s4, I can call the method operate, and I'll pass Shivam over here. Okay, then again, let me just print this. I'll change this to s4. Alright, so if I run this now, you can see that some hash code has been printed. Okay, this is using Lambda and this is using method reference. Alright, now at last we have constructor method reference. It is used when we are calling a constructor to create a new object. The syntax is class name colon new. Alright, let's see. So I'll take another example. I'll just simply create one more interface. Let's say creator, and mark it as a functional interface, and I'll create a method named create. Okay, string name. Alright, it takes an argument string name, and the return type I want to pass using the generics. Okay, so we can have a generic return type. There is no fixed return type. Okay, so at the time of implementing this interface, I'll decide what return type I want to give. Okay, cool. Now I'll take two classes. One is a class named user. It has this field string name, and I'll simply just generate a constructor. Okay, similarly I'll create one more class named product, and it also has a field string, let's say product name. Okay, don't worry, it will all be clear once the example is completed. Okay, and I'll just generate a constructor for this as well. Okay, so we have two different classes, product and user, and we have a functional interface named creator. Okay, that has this abstract method create. It takes a string parameter, and we can have any return type. Okay, so let's say I want to implement this. First, let me just comment this part. Alright, so again, the syntax is, first let me do it using Lambda. So I'll take a creator. I'll first write the interface name, and here in the generics, I will have to pass the return type. So let's say I want to create a user. Okay, so the return type I take as user. Okay, let me call it c1 is equal to, now this method has one parameter, so I'll take this parameter like this, and let's say in this implementation of this method create, I want to return a user. Okay, I want to create a user. So what I'll do, I'll just create return new user, and I will pass the name. Okay, so actually I'm calling this constructor. Okay, this constructor that I created. Alright, now using this c1, I will just call the create method, and let's say I create a user. Okay, like this. So can I convert this into a method reference? Yes, this is also a type of method reference, because here we are actually calling a constructor. Okay, and constructor is also a special type of method. Okay, so it's a single line and we are calling the constructor. So this can be converted into a method reference. Okay, so the syntax is the class name : new. Alright, so I'll take the class name creator. Okay, first I have to take the interface name, and then I'll take the class name. Class name is user. Okay, in this case user : new. Alright, so this represents this. Okay, I know it is new to you and these are very different examples, but these are 4 types of syntaxes that you must learn, and if you are going to practice using some examples, you will definitely get a hold of these. Okay, so using the C2, I will call the create, and I'll create the user Shivam. Okay, like this. So actually this method returns t. So t in this case is user, so actually this will be user. Okay, I'll extract the variable user u1, and this one user u2. Okay, so we can just simply print the name again just to verify. Okay, so I will print u1 dot name, and similarly I can print u2 dot name. Alright, let me run this. Great. So you see that we pass Shivam, a new user was created, and that user was returned here, this user, and here we have printed the name which is coming out to be Shivam. And the same thing we have done using method reference. We wrote the class name : new. Okay, so this represents constructor reference, and then using this object c2, we did c2.create, and a user u2 was created. Okay, and then I have printed the name. Alright, similarly I'll take another example using the product as well. Okay, so we have taken creator product. Let's say c3 is equal to name, and this time we are returning new product. Okay, and I'll pass the name. Alright, so this time I'm calling this constructor. Okay, and using the c3, I will call the create method. Let's say the product is Apple. Okay, Apple Watch, and Similarly, how can I convert it into a method reference? I'll take the interface name product c4 is equal to, so the class name here is product. Okay, so I'll take product colon new. Okay, like this. Then using this c4, I'll again call the create method. Let's say Apple Watch. Okay, so this will return a product. Okay, product, let's call it p1, and this will also return a product. Okay, let me write it like this only, product p2 is equal to c4.create, because create returns this type t and t is product in this case. Okay, so using this again I can print, let me just copy paste p1 dot product name. Okay, we have the field product name. Similarly, p2 dot product name. Okay, if I'll run it, you'll see that Apple Watch has been printed twice. Okay, once using this lambda expression and then using method reference. Okay, so these are all the different method references that were covered in Java 8. I know that the syntax is a bit tricky in the beginning, but trust me, if you practice it a lot, you will definitely get a hold of it. Okay, hello and welcome to my channel, The Curious Coder. This video is part of my ongoing Java 8 series. Today, we are going to explore a really powerful feature which was introduced in Java 8, the optional class. It's a feature whose addition was a complete game changer in handling null pointer exceptions. Now, if you are a working professional, you have probably seen code like these a lot. And if you're a student, you'll definitely come across optional in future. At first, it can seem confusing, but don't worry, in this video, I'll explain optional line by line, word by word, so you can understand it in depth. So what exactly is optional? Optional is a special class in Java that may or may not contain a value. Its main purpose is to help us reduce the chances of running into null pointer exceptions, thereby making our code safer and more readable. So how does optional help avoid null pointers? Since an optional may or may not contain a value, it forces us to think about the case when the value is missing. As a result, we naturally end up handling those cases instead of running into null pointers. Alright, so let's see it in practical. Alright, so let's consider this example. Here we are fetching a user by calling this method getUserById. So we have created a class named user. It has these two fields, id and name, and we are fetching this by calling this method. Okay, now this method belongs to the class user service. Here we have taken a list of users, user 1, 2 and 3, and we take id as a parameter. So we loop on this list, and if we find a match for this id, okay, if we find any match, then we return the user. Otherwise we simply return null. Okay, so null represents that user not found. Okay, user was not there in this list. Alright, so simple. So if I run this code by taking the id as 2, then you'll see that it runs perfectly. Okay, we got a user, and here we are printing the name and id of the user. Okay, but let's say I change the id to 4. Okay, now if I run my application, great, we will encounter a null pointer exception. Okay, why? Because there was no user present against the id 4, and thereby null was returned, and here we called get name and get id on a null reference. Okay, that's why we got a null pointer exception. Okay, so how to handle it? One way is that we can add a null pointer check here like this. If user is not equal to null, then we should print this statement. Okay, now if I'll run it, then nothing will be printed, but there will be no null pointer exception. Alright, but see, the problem here is that in an actual code base, many developers might be working on the same project. Okay, so it's possible that one developer wrote this user service and this method was written, and then another developer came and he just started to use this method. Okay, and somehow he forgot to add the null pointer check. Okay, that is a possibility. Alright, and even if he doesn't forget it here, but let's say then there are many lines of code and after that someone uses this user again. Okay, we have a null check here, but after some lines then we forgot to add a null check there. Okay, that is quite possible. So the thing is, no one is reminding me that we have to add a null pointer check. We need a reminder that tells us that it is necessary for us to add a null pointer check to avoid any null pointer exception. Okay, so that is what optional does. It helps us remind that it is necessary for us to add a null pointer check. Okay, so I'll show you how. What we do is, I'll just replace it with optional like this. Okay, so don't worry about the syntax now, I'll explain everything. So we do optional dot of user, and here instead of returning null, I'll return optional dot empty. Okay, so I am making few changes in my code. Okay, I'll remove this null check as of now, and this get user by id returns an optional user. Okay, like this, and I'll call it optional user. Okay, import, and let me just remove this for now. All right, so what we did was, instead of returning a user directly, we wrapped it inside an optional and then returned it. Okay, so now what exactly is optional? Let's see. You'll see optional is a class. Okay, it is a class and it contains only one field, this value. Okay, this is the only field inside this class optional, and whatever you pass in this generics is the return type of this value. Okay, so since we have passed this user, that is why we are able to, in this return type, you'll see that I've taken the return type as optional of user. That is why inside this optional, the value will be of the type user. Okay, we can wrap a user value inside this optional. Okay, this is what we did. So now what can I do? When I see that an optional value has been returned from here, now it is my duty that I have to put a null pointer check. Okay, why? Because optional may or may not contain a value. Okay, so I'm forced to think that, okay, it might be possible that it does not contain the value. That is why I will have to put a null pointer check. Okay, and I don't even have to put it directly. Optional has given me many methods that let me handle it properly. Okay, so we have one method, optional user dot is present. Okay, so this automatically checks whether the user was present or not. Okay, so it's kind of a null pointer check. Okay, so now what I'll do, I'll print the name and the ID. Okay, so we'll take optional user dot get name. But wait, this is not the type of user, it is type of optional user, and this get name method is inside optional, is inside user. Okay, so how can I print it? So somehow we need to fetch the actual user from this optional user. Okay, so for that we have a method named get. Okay, this get will bring me the actual user. All right, so I can write it like this: user is equal to optional user dot get. And now using this user, I will print the name as well as I will print the ID. Okay, user dot get ID. All right, let me just add name and ID. Okay, so what we did was, I'll just repeat, we changed it to optional of user, and then we added this if condition that if the user is present, then only fetch the user. Now this user cannot be null because we have already added this check. Okay, and we fetched it using this method get, and now using this user, we are printing the name and the ID. Okay, so if I run it for ID2, you will see that the name and ID has been printed. But if I run it for ID4, now nothing has been printed, but there is no null pointer exception. Okay, there is no exception. All right, so now one by one, I'll tell you what these methods do. Okay, so first I'll tell you about this optional dot off. Okay, because this is where we actually created an optional object. Okay, this is where we wrapped our user inside an optional. Okay, so what it does is, if I go inside this off, you will see that it returns a new optional. Okay, so this is where the object has been created. Okay, so if I go here, you'll see that this is a constructor. Okay, so this is actually populating the value, this value inside the value, which is this field. Okay, so this is the constructor. So by calling the optional dot off, I've actually populated the user as a optional user. Okay, so this value field has been populated. Okay, this value field has been populated. Okay, now optional dot empty, in case of this, what happens is that it actually returns empty, and empty is also an optional object, but it does not contain any value. Okay, it's an empty field. So in this case, optional does not contain anything. Okay, now this method is present. If I go inside this, it's a very simple method. It says if value is not equal to null, then return true, otherwise return false. Okay, so it's simply checking whether this value field has been populated or not. Okay, so in case of empty, it is not populated, but in case when we actually populated it by calling optional dot off, then we get something. Okay, then it returns true. All right, now this dot get method, it does nothing. If the value is null, it will return no value present, but if it is not null, then it will return a value. Okay, so somehow if you call this get method without this is present check, then it will return this error. Okay, but here since we added the check, that's why it returned the actual value. Okay, which in this case is user, because this t is of type user. All right, so these were all the methods that were here in the picture. Now so far we have seen optionals methods like isPresent, off, empty and get. Now these are few more methods that optional class contains. One by one, we'll understand each of them with examples. IfPresent is an optional classes method which executes a given action only if the value is present. Alright, let me show you. So now instead of writing it like this, what I'll do is I'll simply take optional user and I'll call this method IfPresent. Okay, here I can take a user and then we can just add this print statement inside this lambda expression. Okay, like this. Alright, so this code has been converted into a single line using this IfPresent method. Okay, so I'll just simply comment this out. And let's say if I run for id 2, great. If I run for id 2, then the user is present, which means this statement will be executed. But if I run for id 4, then nothing will be executed. Okay, so this is how IfPresent works. It only executes this statement when the user is present, otherwise it does not. Okay, now what we are going to do is I'll go inside this method and we'll try to understand what exactly is happening behind the scene. Okay, so I'll teach you line by line what this code represents and we'll look at what exactly is happening behind the scene. Okay, so this IfPresent method takes something called consumer. Okay, it has this argument consumer. So what is a consumer? Consumer is a functional interface. Okay, and it has this method named accept. Okay, it has this abstract method named accept that takes one argument but it returns nothing. All right, so what are functional interfaces? These are interfaces that have a single abstract method and we can implement them by giving a lambda expression. Okay, and that is exactly what we have done over here. Okay, so I'll just break it down in a simpler way. I'll first show you how to implement the interface. Okay, so we have a consumer and we want the argument to be user. Okay, so I'll just simply show it to you how we can actually implement it using lambda expression. Okay, so we'll take a user, we'll take one parameter. All right, why? Because this accept has a single parameter. Okay, so I'll take a parameter like this, then I'll add the arrow, and here we can provide the implementation. Okay, so this implementation is of this accept method. Okay, so here I can actually add this logic. So my logic is that I want to print the user's name and ID. Okay, so here I can print the user's name and ID. Okay, like this. And let me just comment this for now. Okay, so this is how I can implement a consumer interface. Okay, so now if I'll run this, will anything happen? No, actually nothing will happen. Why? Because as of now we have not called this accept method. Okay, we have to call this method. So if I'll do c1.accept and here I will pass the user. Okay, I'll pass my user. So where will I get the user? Optional user dot get. Okay, and let the id be 2. Okay, now if I run it, great. You will see that when we call this method accept, at that point this statement will get executed. Okay, so this is how functional interfaces work. Here we provide the implementation, and then when the method is actually called, this implementation is executed. Okay, so that is kind of what is happening here in if present. Okay, I'll show you. So this is the implementation. I can shorten it a bit. I can remove this, I can remove this, and hey, I can, since it's a single parameter, so I can remove this as well. Okay, so this implementation looks like this, and it is exactly what we have added here. Okay, this is exactly what we have added here. Now the only thing is, whenever this except method will be called, then this statement will be executed. Okay, so I'll just remove this. I just wanted to show you how consumer works. Okay, so here we have added the implementation. Now if the accept method will be called, okay, then it means that it will be executed, otherwise it will not be executed. Okay, simple. So what this if present is now doing, here we have added a consumer implementation, and it has added a check here that if the value is not null, then only call this accept method. Okay, you understand? So if the value is not null, then only this accept method of this consumer interface has been called, and that means that this statement will be only executed when the value is not null. Okay, so when the value was null, it was not executed, and when the value is not null, then this was printed. Okay, so this is how if present works. Okay, so if you look at it inside, it's actually quite simple. You just need to understand how this functional interfaces work and what exactly is happening behind the scene. Okay, now or else is an optional classes method that returns the value if it is present, otherwise returns a default value. Okay, let me show you. So what I'm gonna do is I'll take the optional user, and let's say I call this method or else. Okay, and here I provide a new user that has some ID, let's say -1, and I name it a default user. Okay, something like this. Alright, so this will actually return me a user. Okay, simple. Let me just comment this. Alright, so what exactly is happening? We had this optional user and we wanted an actual user out of it. Okay, but the only problem is that there is a possibility that this optional does not contain anything. Okay, so what I've done here is that if it does not contain anything, then in that case I've defined a default user for myself. Okay, so this or else works when it does not have anything. Okay, so I'll just simply print this and we'll understand. Okay, we have fetched a user. Using this user, I'm printing the name and the ID. Okay, so if the ID was 2, great, then the actual user against this ID was printed. But let's say if the ID is 4, then in that case this or else will be triggered and it will return the default user. Okay, so this default user will be returned. Okay, simple. Now if I look inside this method, you will see that it's a very simple implementation. It simply says that if the value is not null, then return the exact value. If it is null, then return whatever we have passed in the argument. Okay, so we passed this default user in the argument, and that is why it was returned. Okay, now or else get is an optional classes method that returns the value if it is present. Otherwise, it calls a supplier to generate the default value. Alright, let me show you. So now what we can do is we can actually replicate this entire thing using a different method. Okay, let me show you how. Instead of or else, I will simply write or else get. Okay, and here instead of passing the user directly, I will just simply change it to a lambda expression. Okay, like this. That's it. Alright, so if I'll just run it for 2, great. You will see that it returns the user Amit, but if I run it for 4, then it returns the default user. Okay, so this is what is happening here. It works the same way as or else works. The only difference is that here it takes a supplier implementation. Okay, and here we can pass on the user directly. Alright, that's the difference. So what is a supplier? Supplier is a functional interface which has this abstract method named get. Okay, and it has some return type. Alright, so that is why we have to pass a lambda implementation here. Okay, so how can I implement a supplier? Again, it's simple. I want to supply a user. So let's say I take a parenthesis. Okay, since there is no argument in this get, so I'll simply take parenthesis without any argument, and we can just return a user. Okay, so like this. Alright, and that is exactly what we have done over here. Okay, so this is an implementation of this supplier. Alright, now when will this be executed? When we'll actually call s1.get. Okay, then only this lambda gets executed. Okay, and that is what is happening here in this or else get. Here what they are doing is, if the value is not equal to null, then simply return the value. But if it is null, then call the get method on this implementation. Okay, so this means that when the value is not null, then the exact user will be returned. But if it is null, then this lambda implementation that we have provided here, it will trigger the get method, which means that this statement will be executed and a default user will be returned. Alright, this is how this or else get works. Now or else throw is an optional classes method which returns the value if it is present. Otherwise, it simply throws an exception. Alright, let me show you. So what I'll do is, I'll simply take the optional user and I'll call this method or else throw. Okay, and here we pass on the implementation where we are just returning some exception. Let's say I want to return a runtime exception that says user not found. Okay, something like this. Alright, so this time I'm saying that if I find the user, then it should just simply return that user. Otherwise, we should throw some exception. Okay, so we have a method for that as well. Alright, so let me just run it for 2. Okay, alright, I have not added the print statement. Just a second. Yeah, so if I run it for 2, then the value gets retrieved. But if I run it for 4, in that case, we get the exception. Okay, that user not found. So it provides you a provision that if you want to throw some exception, that also you can do. Okay, now inside this method also, it simply takes a supplier, and if the value is not null, it returns the value. If the value is null, then it calls the get method on this supplier. Okay, and if you look at it carefully, this is a supplier implementation. Okay, the same as we discussed over here in or else get. Alright, now off nullable is an optional classes method which is used to create an optional that holds the value if it is non-null. Otherwise, it returns an empty optional. Alright, let's see. So we have already seen that we can use optional.off to create an optional. Okay, if I pass a user inside this optional.off, then an optional of this user will be created. Okay, similarly, we can also use optional.off nullable. Okay, like this. Both perform the same action. What they do is they actually create an object of optional. Okay, now the difference is that in case of this off method, we actually cannot take a null value. Okay, so let's say, let me just comment this out for now. Let's say I have a user which is null. Okay, by chance it's null, and if I pass it inside this method, then it will throw me some exception. But in case of off nullable, there won't be any problem. Okay, that is the only difference. So I'll show you. Let's say I just run it. Great, so you can see that we get a null pointer exception. Why? Because if I go inside this, you will see that here it calls a new optional, and in this private constructor we have this condition that says objects.require non-null. Okay, so it says that a non-null object is required. So if the object will be null, then it will throw a null pointer exception. Okay, and that is what happened when we use this user along with optional.off. Okay, but in case of a off nullable, if I just run it, there will be no issue. Okay, because off nullable has that handling. So it simply says that if the value is null, then simply return optional.empty. Okay, so it is returning optional.empty. Alright, so that is the only difference. Okay, hello and welcome to my channel, The Curious Coder. Today we'll be learning about one of the most powerful and game-changing features introduced in Java 8, Stream API. Trust me, after this video, your entire approach to coding will change. So what exactly is a stream? A stream is a sequence of elements that supports various operations to process data. Formally speaking, stream is an interface introduced in Java 8 that provides methods to perform data processing in a functional style programming. Now, don't worry if that sounds a bit heavy. So far, what do we know? Stream is an interface, it has a lot of methods, its purpose is to process data, and it does so in a functional programming style. Alright, now what does all of this actually mean? Let's understand it practically. So, as I told you, stream is actually an interface, and as you can see, it contains a lot of methods. Okay, we have this filter, map to int. Similarly, there are a lot of other methods inside this interface. Okay, so if we look at this method filter, you'll see that it takes a parameter of this type predicate. Alright, so if I go inside this, you'll see that predicate is actually a functional interface. Okay, now what are functional interfaces? Any interface that contains a single abstract method is called a functional interface. Okay, so this interface predicate contains only one abstract method, which is this one, boolean test. That is why it can be treated as a functional interface. Alright, now when I say that stream supports functional style programming, this is what I actually mean. That the methods inside stream, they work with these functional interfaces. Okay, so you can see that filter works with predicate. Similarly, map works with this interface function, okay, which is another functional interface. Alright, so this is how stream supports functional style programming. That the methods inside this interface actually work with functional interfaces. Okay, now what's the benefit of having these functional interface? The benefit is that we can implement these interfaces, we can implement these methods in a very short and concise syntax. Okay, and that is what we call Lambda expressions. Alright, let me show you. So what I'm going to do is, in reality, we have 3 to 4 very important functional interfaces that we use quite a lot along with streams. So one by one, I'm going to show you how we can implement those using Lambda expressions. Okay, and that would be very helpful in the video when we'll move ahead. Okay, so first I'll start with predicate. What we are trying to achieve is that we want to implement this method test. Okay, it takes a single argument and it returns a boolean value. Okay, so how will I do that? I'll simply write predicate. Let's say it is of the type integer. Okay, so this means that whatever I pass here is actually of the type of this argument. Okay, so let's say I name my object something p1. Now from here I will start the Lambda expression. Alright, so how does it work? Since this method contains a single argument, so I will also take a single argument like this, and I can name it anything. Let's say I name it num. After that I will have to add an arrow operator, okay, then followed by the curly braces and a semicolon. Alright, this is the syntax. Okay, so whatever I write between these two curly braces actually represents the implementation of this method test. Okay, so whatever I am writing here is representing the implementation. Okay, now what do I need to implement? Let's say I simply want to check whether this number is even or not. Okay, so what I can do, I can simply write if num mod 2 is 0, then return true. Okay, otherwise return false. Alright, so this is how I have implemented this predicate interface. Okay, it is very simple, very short and very concise, and this is what we call Lambda expressions. Okay, now I could have simplified it a bit more. Instead of writing all this, I could have simply return num mod 2 equal to 0. Okay, we could simplify the if else like this. And now that's the beauty of Lambda expression, that when the implementation is of a single line, okay, in this case the implementation is of a single line, so I can remove this curly brace, and I can remove the semicolon, and I also don't need the return keyword. Okay, so I can simply write it like this. Alright, that's the whole implementation. We just have to write num, which is the argument, okay, which is this argument here, and then I'm saying num mod 2 equal to 0. So this means that I want to return true if the number is even, Otherwise I want to return false. Okay, similarly let's see some other interfaces. We have this interface function. Okay, here it takes an argument, but it does not return boolean. Okay, it can return anything. All right, whatever you pass here, it can return anything. All right, let's see. I'll simply, let's say I take integer and integer only. Okay, let me call it f1. So this time again, here we have a single argument. Okay, so I will just take a single argument. Let's say I take it as number only, and I want to return the square of this number. Okay, like this, num into num. All right, so this is how I can provide an implementation. Now again, it is of a single line, so I will remove this, I'll remove this, and I will remove the semicolon and also the return keyword. Okay, so this is how I can implement this interface function. All right, now we have two more interfaces. There is this interface consumer. Okay, it is also very important. So it is a functional interface, and you will see that it takes a single argument, but it has no return type. All right, so I'll give one example. Let's say I'll take integer only again, and what I need to do is it takes a single argument. Okay, so again I'm taking a number, and let's say I just simply want to print this number. Okay, we don't have to return anything from here, so I'll simply print it, system.out.print number. All right, like this. Again, it's a single statement. I'll remove this and I'll remove these two, and this I can write over here like this. Similarly, there is one more. There is an interface supplier. Okay, so it's kind of opposite to consumer. What it does is it does not take any argument, but it has a return type. All right, so this can be used. Let's say the return type I want to give as integer. Okay, so I'll simply say s1. Now this time I don't have any argument, so I'll simply write it like this, followed by this arrow operator. And let's say I want to return some value. Okay, simply I want to return math dot random. I'll return a random number. Okay, and let me cast it to int. All right, that's it. Simple. Now again, now why did I do that? Because this does not take any parameter, but it has some return type. Okay, that's why I returned some value. And in case of a consumer, it took a parameter, but it didn't have any return type. Okay, so that's how we implemented it. All right, so again in this case, it's a single line. I'll remove this, and I'll also remove the return statement. Okay, so we can simply implement it like this. All right, so these are 4 interfaces that I implemented. You will see that it's a very simple implementation. We can do all this in a single line. Now so far we have seen that stream is an interface. It has a lot of methods and it uses functional programming. Now let's understand how it actually processes the data. So this is the data that I have taken. It's a list of integers, and somehow I want to convert this list into a stream. Okay, so how can I do that? It's very simple. We can just call this method named stream. All right. Now many developers get confused here. The confusion is that whether stream is an interface or whether stream is a method. Okay, so stream is actually an interface only, but we also have a method named stream, which we use when we want to convert any collection into a stream. Okay, so I'll repeat. Stream is also a method which we use when we want to convert any collection into a stream. Okay, so you'll see that the return type of this method is actually stream only, which is the same interface that we just saw. Okay, now this stream is inside this interface named collection. Now what is collection? Collection is actually a parent interface of many data structures. Okay, so list is one of those data structures. All right, I'll show you. You can see that one of the implementation is list. Similarly, we have set as well, and we have other data structures as well. Okay, we have DQ and many more. All right, so any collection can be converted into a stream just by calling this method stream. All right, so that is what we have done. We have converted this list into a stream by calling the method stream. Okay, so I'll just extract a variable. Great. Okay, so we got a stream. Now what can we do? We can perform various operations. Okay, so let's say I'll start with a very simple operation. We just want to print all the elements. Okay, I want to print all the elements. So for that, I'll call a method named for each. Okay, And here I'll say that for every element, we just have to print the element. Alright, like this. Cool. So you'll see that this is actually a Lambda expression. And if you look at it carefully, this for each method takes a consumer, and this Lambda expression is actually an implementation of consumer only. Okay, you can see here that this is what we implemented a little while ago. Alright, so that is how we can write it. Now if I'll just run it, great, you can see that all the elements are printed. Okay, so this is one of the method which loops on every element, and we can just provide a consumer implementation here and that will be executed. Okay, so we have written a print statement. That is why all the elements are printed one by one. Okay, now I'll take another example. Let's say this time I want to print only the even elements. Okay, only the elements that are even that I want to print. So what I can do is, okay, first one thing that I want to do here, I'll not write it like this. Okay, we don't need this stream variable. We can do it directly like this only. List.stream dot for each. Okay, generally we do it like this. Okay, and I'll tell you why. Alright, in a little while we'll get to know why don't we extract it in a variable. Okay, so for now we'll do it like this. Now let's say I want to print only the even elements. Okay, so what can I do? List.stream.filter. Okay, so we have another method filter. So it will take every element and we can add some condition. Let's say the condition is element mod 2 equal to 0. Okay, and that's it. So what I'm saying here is that this filter takes a predicate, and this is how we give a predicate implementation. So here we can pass on a condition, and what filter will do is that it will filter out all the elements which does not satisfy this condition. Okay, so only for the elements that will return true for this, those will be kept in the stream, and rest all will be removed. Okay, and one more thing, this filter actually returns a stream only. Okay, so we still have a stream, so we can still again call another method. So now what I'll call for each, because I also want to print the elements. Okay, so again I'll say for every element I just simply want to print the elements. Alright, like this. So what filter did, it will filter out all the elements that does not satisfy this condition. Okay, so only the elements that satisfy this condition will remain. So after that only the even elements will be present, and here we are printing those elements. Okay, so I'll show you. Let me just comment this out. Great. So you will see that 2, 4 and 6 have been printed. Okay, and as I told you, this filter takes a predicate. Okay, this you should know for interview point of view. Okay, cool. Now I'll perform another operation. What I want to do is I'll just simply take a stream and I want to print the square of all these elements. Okay, so how can I do that? So again, I'll call a method named map. Okay, and it takes every element and it maps it into its square. Okay, like this. Alright, and then I want to print it because map also returns a stream, so I can still call another method. So I call this method for each, and here I'm just printing every element. Out.print element. Okay, now here also we have given a lambda expression, and this one is actually of the argument is function, and this expression is of the type is a lambda expression of function. Okay, good. So now this map, what this map has done is that it will take every element and it will convert it into its square. Okay, and then here we are printing those. All right, so I'll run it again. Okay, let me just comment this. Great. So we'll see that all the elements are printed. All the squares are printed. 1, 4, 9, 16, 25, 36. Okay. Now I could have also added a filter here. What I can do is I'll just simply change the example. First, I want to filter all the elements and I only want to keep the even elements. Okay, like this. And after keeping all the even elements, I want to map it to their square and then I want to print them. Okay, so that also I can do. Great. 4, 16 and 36. Alright. So first I called a filter that filtered the elements. Now since it still returns a stream, so I can call another method. That's why I called map. Now map has mapped these elements to their square. Now it also returns a stream only. This map also returns a stream. So I moved ahead and I called for each. And now using for each, I am printing all the elements. Okay, so filter is taking a predicate implementation, map is taking a function implementation, and for each is taking a consumer implementation. All right, I'll take another example. Let's say we have a list of employees. Employee is a class which has these fields ID, name, and department. Now, in an interview, someone asks you to print the name of all the employees whose department is tech, and do this using functional programming. So, how will you do this? Let's find out. So, we have this list of employees. Inside this class employee, we have ID, name, and department, and we have created getter methods for all these fields. Okay, I have a get ID, get name, and get department. Okay, now what I want is, I want all the employees whose department is tech, and I only want to print the name of those employees. Okay, I only want to print the name. Alright, so how can I do that? First, I'll take the list and convert it into a string. Okay, then I'll just simply filter out all the employees whose department is tech. Okay, so I'll take an argument employee and I'll simply add a condition that employee dot get department dot equals tech. Okay, this is how I can add a predicate condition. Okay, filter takes a predicate and the condition says that all the employees whose department equals to tech, those should be kept and rest all should be filtered out. Okay, now what I want is that as of now in this list we only have employees. Okay, you can see that here also we are looping on employees, and using this employee reference we have called this get department method. Okay, but in the end what I want is I want the name of those employees. Okay, I don't want the employees, I want to print the name. Okay, so what I can do is I can just take a map. I can call this method map, and we have employee, but I will map it to employee dot get name. Okay, and now I will just print all these names like this. All right, system.out.println name. Okay, so what we did was first we converted the list into a stream, then we filtered out all the employees whose department is equal to tech, then here we mapped the employee into its name. Okay, so now after that this stream has become a stream of names. Okay, so here when I loop on it using for each, here I will get a name. Okay, you can see that this is string and this is of the type employee, and then here I'm just printing all those names. All right, so this is how filter, map, and for each works. Okay, so I'll show you this as well. Great. So you will see that Amit, Rahul, Vikas, and Arjun. So Amit, Rahul, Vikas, and Arjun, all these have their department as tech, and you'll see that not all the employees are printed, only their names are printed. Okay, cool. Now let's look at another important method, collect. Collect is a method inside stream interface which takes all the elements from the stream and transform them into some final result, like a list, set, or a map. Alright, so if you want to convert your stream back into a data structure, you can use collect. Okay, so let's see how. So I'll take the same example. Initially, I had a list of employees. I converted it into a stream. Then I did some filtering, some mapping, and in the end, I'm looping on this stream and I'm printing all the names. Okay, but let's say I don't want to print all the names. Instead, I want this stream to be converted back into some data structure. Okay, so after the filtering and the mapping, I don't want to print right away. I just want to convert it back into some data structure. Okay, so for that, I can use the method collect. Okay, now let's say I want it in the form of a list. So for that, I will have to write it like this, collectors dot to list. Okay, and here I can add it in some variable. All right, let's say I say names. All right, so eventually I will get a list of string. Okay, so I had a list of employee. I filtered all the employees whose department were tech. Then I mapped it into employee.getName. So at this point of time, when this map is called, now we have a stream of names. Okay, a stream of strings. And then we convert it back into a list. That is why we get a list of string. Okay, we get only the names, because we have mapped the employee to employee.getName. Okay, so this is how we can use collect. Now if I wanted it to be in the form of set, so for that I could have called toSet, and in this case it would be a set of string. Okay, cool. Now I will take one more example. Let's say I want to convert this into a map. Okay, now map is a bit tricky because for map you will have to define the key as well as the value. Okay, so you will have to define what key you want to take and what value you want to take. So let's say we have this list of employees and I want to convert it into a map whose key is the employee ID and value is the employee name. Okay, let's say I want to convert it into something like that. Okay, so how can I do it? I'll take the employee, I'll convert it into a stream, I'll call the method collect, and here I can just write collectors dot to map. Okay, but it does not end here like this, because now you will have to define what is the key and what is the value. Okay, that is why this to map takes two arguments. The first one defines the key and the second one defines the value. Okay, and you can see that both these arguments are actually of the type function. Okay, so in both these arguments we have to provide lambda expressions, and those lambda expressions, the first one will represent the key and second one will represent the function. Okay, lambda expressions will be of the interface function. All right, so we have already seen how we implement function. Let's say I want the key to be integer. Okay, and I have my argument as employee, so I'll take it like this: function employee comma integer. Let's call it f1. Okay, so I have employee that I know, and I want to convert it into, I want to fetch the key out of it. Okay, so I want to map it into the ID. Sorry, I want to fetch the ID out of it. Okay, so this will be my first lambda expression. Similarly, I'll create one more. I have an employee, and from this employee I want the name. Okay, that will be my value. So I have this employee, and I'll simply do employee dot get name. Okay, like this. So this is the first lambda expression which will represent the key, and this is the second lambda expression which will represent the value. Alright, so here I will just add f1 comma f2 like this. Got it? So in this method toMap we pass on two function arguments, and first one represents the key and second one represents the value. Okay, so the key will be ID and the value will be name. Alright, let's see. I'll just extract a variable. Great, so let me call it employee map. Okay, so you'll see that the key is of the type integer and value is of the type string. So now I'll just print this map to show you what exactly is the final result. Okay, so we have this employees map. If I simply just run it, great. So you will see that we have a map where key is the ID. Okay, we have all the IDs, and value is their corresponding names. Okay, so against 1 we have Amit, similarly against 2 we have Neha, and so on. Okay, so this is how we can use collect along with these various functionalities: collectors.toList, toMap, and toSet. Now let's understand another very important concept: intermediate operations and terminal operations in streams. First, let's talk about intermediate operations. These are the operations that transform or process the data in a stream, but they do not actually produce a result of their own. Some common examples of intermediate operations are filter, map, sorted, etc. Terminal operations are the operations that trigger the execution of the stream and produce a final result. Examples of terminal operations include collect, for each, count, etc. Alright, let's see it in practical. So I have taken the same example. We have a list of integers, we convert them into a stream, then we apply a filter, and we keep all the even elements. Then we provide a map, we apply a map, and we convert these elements into its square. Okay, then we call for each and we print all the elements. Alright, so here filter and map are intermediate operations and for each is a terminal operation. Okay, why? Because filter returns a stream, and that is why even after calling this method I can still do further processing. Okay, because I still have a stream. Similarly, map also returns a stream. So that is why I was able to call this method for each, because after calling this method, I still had a stream. Right. So that is why these are called intermediate operations. But for each actually does not return anything. That is why it is a terminal operation. Okay. Because it will end the stream and now we cannot do any further processing. Okay. Similarly, we have other examples. I have a method named count. Okay, so this count returns a long value, but again, it does not return a stream. Okay, so when we call this method, the stream has been ended. Alright, now what's this method used for? It actually returns the count of all the elements that are remaining in this stream. Okay, so I'll just print this long count. Alright, so it will actually return the count if we just print this. Great, so the count is 3 because after we applied the filter, only 3 elements were remaining. Okay, count is another terminal operation. Similarly, we have collect. Collect is also another terminal operation because this also ends the stream and it converts the stream back into some data structure. Okay, like in this case, we have converted it back into some list. Alright, list of integer, let's call it a final list. Okay, now there is a very important interview concept that comes from this topic. The thing is that once a stream is used, it cannot be reused. Basically, once you call a terminal operation on a stream, then you cannot reuse a stream. Okay, let me show you what I'm trying to say. If you remember, initially we just took this list.stream and we extracted it in some variable. Okay, like this. And then let me call it just s. Okay, and then we applied filter or map or anything on it. Okay, we can do it like this also. Right? We can just call this method stream, we can add it in some variable, and then we can call these methods. Okay, so let me run it like this. Great, so you will see that there is no issue in this. Okay, but let's say I took this s again and I called s dot, let's say anything, I called s dot filter. Okay, again, and I'm trying these elements and I write anything, element mod 3 equal to 0. Let's say this is the condition that I want to give. Okay, so now if I'll run my project again, yes, so we will have some exception, and the exception says that stream has already been operated upon or closed. Alright, so what I mean by that is that when we had a stream, we can perform as many intermediate operations as we want, but after we call a terminal operation, then the stream has been closed. So you cannot use this variable again to call another intermediate operation. Okay, that will give you an error. That is why it is not recommended that you extract this in some variable, because this kind of code is possible and it will throw you some exception. Okay, because at this point, at line number 20, the stream was actually closed. Now, if you will try to call another intermediate method, it will give you some exception. Okay, so this is a very important interview question that is asked a lot. Okay, so you should know about this. Alright, so I'll just change it back to list.stream like this. Okay, let me just remove this. Great. Alright, so at this point the stream has been ended. Okay, now there is one more interview question that comes from this topic. It says that all the intermediate operations are lazy loaded and the terminal operations are eagerly loaded. Okay, so what exactly do I mean by that? By lazy loading, I mean that these methods are not called until we add a terminal operation. Okay, I'll show you this. Let's say if I just remove this operation and I end it here. Okay, I just write list.stream.filter.map. Okay, and let me just change the implementation a little bit. Okay, I'll take a completely different example altogether. Alright, let me remove this. So I have a list, I take a stream, let's say I call a method filter. Okay, so I'm taking every element and I provide some implementation here. Okay, so here I am writing a print statement as well, just to show it to you.
I'm saying filter method called. Okay, and I'm saying if element mod 2 equal to 0, return true. Okay, if you remember it, we did it like this initially. Okay, now it's not a single line implementation, so that's why I cannot remove these curly braces. Okay, similarly I'll call dot map, and here as well I'll do kind of a same thing. I'll take an element, and let's say I write another print statement that says map method called. Okay, and my implementation is that I am returning element into element. Okay, and I just end it over here. All right, so I've called a filter method, I've called a map method, I've added print statements in their implementations, and I've not called any terminal operation. Okay, so if I'll just run my project, great. So you will see that these statements have not been printed. Okay, so this means that filter and map has not been called at all. Okay, it has not been executed. Now why? Because they are lazy loaded, which means that they will only be executed when we'll add a terminal operation on them. Okay, so let's say now I just add a simple operation dot collect collectors dot to list. Okay, so I've done nothing else. I've just added another operation, which is a terminal operation. I'm not even using this list. Okay, I've just added this method, and now if I'll run it, great, you will see that these statements have been printed. So this filter and map has been called again and again, like again and again, because they loop on this list and filter out elements one by one. Similarly, map all the elements one by one. That's why you see so many print statements. But the crux is, my point is that both these methods were executed only when we add a terminal operation. Okay, so this is what lazy loading and eager loading is. Again, it's a very important interview topic, and you should definitely know this. Alright, now these are a few other commonly used stream methods. Let's go through them one by one and understand how each of them works. Find first is a terminal method that returns the first element of the string. Alright, let's see. So I have taken this list of different names. Let's say I want to convert it into a stream and call this method find first. Okay, so this will return the first element from this list. Okay, so let me just extract it in some variable. Okay, so this actually returns an optional. So if I actually want to print it, I will have to call this method get. Okay, first dot get. Alright, like this. Okay, if I run it, great. So we'll see that Aman has been printed because Aman is the first element. Okay, now generally we use this find first along with some condition. Okay, so generally we add a filter, and let's say I apply a filter that says that the string starts with, let's say, A. Okay, or let me call it some other example. Let me take it as R. Alright, now if I run it, okay, so it will return Raj. Alright, why? Because this was the first string that starts with R. Okay, so first I applied a filter, and then as soon as it gets the first element, it will simply return it. Okay, find any is a terminal method that returns any element from the string. It is not guaranteed that it will be the first one. Alright, let's see. So in this example only, instead of find first, I can just simply call find any. Okay, so it is not guaranteed that it will return the first element. It can return any of the element, but generally when the list is this small and we are calling this find any, it mostly returns the first one only. Okay, so you'll see that it returns Raj only, but there is a concept of parallel processing. Okay, sometimes we work parallelly on these streams, and at that point of time this method is used quite a lot. Okay, because at that time it can return any result. Okay, now any match is a terminal method which returns true if any of the element matches a given condition. So we have these names. Let's say I convert it into a stream and call the method any match. Okay, now inside this method we can actually pass a predicate implementation. Okay, so I can pass a lambda expression with some condition. So let's say I say that if any of the name starts starts with R. Okay, this is a predicate implementation that I can add here. So what any match will do is that if any of these element satisfy this condition, then it will return true. Okay, so this method actually returns a boolean. Okay, otherwise it will return false. So I'll just extract it in some variable. Let me call it boolean value. Okay, and we'll just simply print it. All right, if I run it, great. So it returns true because we have elements that start with R. Okay, but let's say I just write starts with Z. Okay, now if I'll run it, so now it will return false because none of the element starts with Z. Right, now all match is a terminal method which returns true if all the elements match a given condition. Okay, let's see. So if I'll just replace it with all match, okay, and let's say I just test it for R. Okay, so if I run it, it will return false because all match says that if all the elements would have been started from R, then only it will return true. Okay, so let's say I provide a different condition. I can just simply say str.length is greater than 1. Okay, so we have all the strings whose length is greater than 1. Now if I run it, so now it returns true. Okay, so this is how all match works. Now none match is a terminal method which returns true if no elements match a given condition. Alright, let's see. So if I replace it with none match, so none match returns true if none of the element matches the given condition. Okay, so if I'll run it for this, it will return false because all the elements matches this condition. Let's say I change it back to str.starts with R. So again you'll see that it will return false because most of these names start with R. Okay, in fact if I'll do it for A, then also it will return false because Aman starts with A. Okay, so it requires that none of the elements should match that condition. Okay, so let's say I say starts with Z. Now if I'll run it, so now it returns true because none of the elements start with Z. Okay, so these were a few of the methods that we can use quite a lot. Okay, whenever we want to fetch some boolean value in the end. Okay, now sorted is an intermediate method which returns a stream with all the elements sorted. All right, let's see. So I have taken an unsorted list, and if I simply just call numbers.stream.sorted, so this will return me a sorted list. Okay, but it is an intermediate method, so I will have to call a terminal operation. Let's say I call this, and now if I print all the elements, okay, if I print all the number, you will see that these are in sorted format. Okay, so sorted is quite simple. We can just directly call it and we can sort any list. Alright, now let's talk about another interesting concept, primitive streams in Java. Normally stream works with collection, but Java also provides special streams for primitive types like int, long and double. These are called int stream, long stream and double stream. Alright, let's look at them in practical. So we have this interface named int stream. If I go inside this, you'll see that it is another interface which is quite similar to stream. As you can see, it has all these methods. We have filter, we have map, and we have various other methods. Okay, but this is not actually a stream. It is a different interface and it is specific for primitive data type. Okay, so int stream is specific for int only. Okay, so we use it with some int values. Let's so how can I create it? It's very simple. I can just call int stream dot range. Okay, so it has this static method inside it which we can call, and in the range I can just pass the range. Okay, so 1 to 5. Okay, so this means that it's a stream of 1, 2, 3, 4 and 5. Alright, now using this int stream we can perform various operations. Let's say I want to calculate the average. Okay, so I can just call this method average. I'll just extract this variable and I'll simply print it. Okay, average dot get as double. Okay, so in the end we have to convert it into a double value. Okay, so if I run it, great, it will return the average of all the values. Okay, Similarly, we have a method named sum. Okay, if I want the sum of all the values, so it will return me an int value. Okay, int sum, and I can just simply print this as well. All right, great. So you can see it gives me the sum of all the values. Okay, similarly, we have other interfaces. We have this interface double stream. This one is meant for double values. Okay, so how can I create it? I can create it like this: double stream dot off. Okay, and here I can pass any value that I want. Okay, let's say I pass random double values. So a stream of double has been created. Okay, similarly, this also has this method average, and we have other methods as well. Okay, so I'm just showing you a few of them. Dot out dot println double stream dot average dot get as double. Okay, and we can run it, and it will just give me the average of these three numbers. Okay, similarly, we have another interface named long stream. Okay, so this also I'll show you. We have this interface long stream. Okay, this also we can create in the same fashion. We can just say long stream dot off, or we could have used a range as well, and let's say 1, 2.3, 4.5. Okay, we can give different values here. So okay, we have to give these long values. All right, okay, sorry, my bad, it's long, so we can take values like this. Okay, so similarly, I can perform operations on long stream as well. All right, so the crux is that for primitive data types as well, we have a stream interface. We have different interfaces for all of them, but you should know that this is different from the actual stream interface. Okay, that you should know. All right, now let's talk about parallel streams. Normally, streams process the elements sequentially, one after another, but sometimes we want to process large collections faster by using multiple threads. That's where parallel stream comes in. It allows the stream to process elements in parallel. Using this parallel stream method, we can make operations faster, especially for larger data sets. But for small collections, it may not make much of a difference, but still for large collections, we can use this method. Alright, let's see. So we have this list of names. Now instead of calling the method stream, I will call dot parallel stream. Okay, and then I can perform the same operations that I used to do earlier. Alright, so I can call a filter method. I can just simply filter out some values. Let's say I want to add a condition that string starts with R. Okay, and then I want to call for each, and I'll just take every name and we'll just print these names. Okay, so the only difference is that instead of running sequentially, instead of looping on the list sequentially, now this stream will work in a parallel way. Okay, using multiple threads. All right, so if I run it, great. So you will see that these names are not printed in a sequential order. Okay, you see that Rahul is printed first, then Raj, then Ria, Reena. Okay, so they are not in their actual order. This is because we were processing on this stream in a parallel way. Okay, so it would have actually been processed faster because multiple threads are being used. However, when it's a very small list, so it won't make much of a difference. But when we are working with larger data sets, at that point of time, if we want to process faster, then we can use parallel stream. Okay, because it will open multiple threads. Alright, hello and welcome to my channel, The Curious Coder. This video is part of my ongoing Java 8 series, and today we are going to talk about another important feature of Java 8, the new datetime API. In Java 8, a new package called java.time was introduced. This was added to fix the shortcomings of the older classes like date and calendar. Now what exactly was improved? Earlier, the old classes were mutable, which made them error prone. But in the new package, all classes are immutable and thread safe, making them much safer to use. The old classes were also confusing and poorly designed, but the new package provides clear and separate classes like local date, local time, and local date time, each serving a specific purpose. Also, handling time zones was quite complicated before, but now it is much simpler with dedicated classes like zone date time and zone ID. Alright, Now that we understand why this new API was introduced, let's start exploring it step by step. So this was the package which was introduced in Java 8. As you can see, I have already imported it. I've imported all the classes from this package. Okay, so let's start by looking at some of the important classes that this package contains. First, we have a class named local date. This class represents the date. Okay, but it does not have the time component. Alright, so for time, we have another class local time. It only has the time component. It does not contain any date. Okay, then we have another class local date time. Okay, so this contains both date as well as time. Alright, so let me show you how we can create them. It's very simple. We can just call a static method dot now. Okay, so this will create the current date. Similarly, we can call this method on local time and it will give me the current time, and this local date time also has now and it will give me the current date time. Okay, so we have these three classes and we can create the objects of these using this method named now. Okay, so let me just print this ld. Okay, let's just copy this. Alright, so if I run it, great. So you will see that the first one contains the date, contains only the date. Then the local time has the time component, and in this local date time, we have both date as well as the time. Okay, cool. Now there are other ways of creating these dates. Okay, so here we have only created the current date. Similarly, we can create a date for, create a specific date as well. Okay, let's say we want a specific date or a specific time. So for that, we have another method which is local date dot off. Okay, so here we can specify the year, month, and the day of the month. Okay, so let's say the year is 2025. I want the year as 2025, the month as 3, and the date as 12. Alright, so I can save it inside this variable. Okay, so this is how I can create a date of, I can create some specific date. Okay, similarly, I can also create a specific time. We have local time dot off. Now here you can pass hour, minute, second, and also nano of second. Okay, so I'll use this one, hour, minute, and second. So let's say the hour is 18, minute is 25, and second is 50. Okay, like this. Similarly, for LDT, we have local time dot local date time dot off. Okay, so here we can specify all these things: year, month, day, and then hour and minute, and then second as well in this method. Okay, so that's what I'll do. Let's say 2023 and month is April. Then we have some date, let's say 13, and time is 12, 30, and 21 second. Okay, so this is how using off method we can create a specific date, a specific time, and a specific date time. Okay, now if I print these, great. So you'll see that the date, updated dates have been printed. Okay, so this is 2025, then we have this time 1825, and here we have this date time 2023 and 12/30/21. Okay, now what else? I can also change these dates. Okay, so we have some methods like, I'll show you, ld dot plus. Okay, so you can see that I can add some days, I could add months, I could add weeks, or I could add years. Okay, so let's say I just add a few days. Okay, so in this date, let's say I just want to, in this date, I want to add a few days. Okay, so I add 3 days. Similarly, in LT, we have plus hours, plus minute, plus nanos, plus second. Okay, so we could add hour, minute, or nanosecond or second. Let's say I add some minutes. Okay, so plus minutes, I add 12. Okay, and similarly, we also have LDT, and here we have both the options. We could add days, minutes, hours, or we could just add seconds, weeks, years. Okay, and also we can minus as well. We can subtract these things. Okay, so what I'll do, I'll just minus a year. Okay, so minus years, let's say 3. I reduce 3 years from it. Okay, so now if I run it, what exactly will happen? Let's see. All right, so you will see that the dates are actually same. Okay, this is 2025, 312, and all these are exactly same. Okay, if you'll check it carefully. So why didn't it work? Now see, as I told you in the beginning, if you remember, that these classes are immutable. Okay, so what does immutable mean? That they don't change the same object. Okay, like we created this object here, like local date dot now. So the same object does not get changed. When we are calling this method plus days, another local date has been returned. Okay, so if I'll just do it like this, that ld dot plus date, it will not change the actual object. Okay, instead a new object has been created when I call this plus days. So the change will be reflected only if I'll change my reference variable to this new object. Okay, so ld dot plus days actually returned a new object, and this reference object, this reference variable that I created earlier, only if I explicitly change it to this object, then only the change will be reflected. Okay, this is what immutability means, that the existing object is there, it's still in the memory, but when we are calling these methods, a new object has been returned. Okay, so now when I'll do it like this, okay, so all these methods are returning a new object, and we have explicitly said that these reference variables should now point towards this new object. Okay, now the change will be reflected. All right, let me show you. Great, so you can see that the day was 12, but now the day is 15 because 3 days have been added. Similarly, here 12 minutes have been added. So now the minutes are 37 instead of 25. And here 3 years have been reduced. So that's why the year is 2020. Alright. So this is how these methods work. Now what else can be done? We can also perform comparisons between these dates. Okay, let me show you. Let's say I take this date LD, and I can simply call this method is after. Okay, and here I can pass another date. Let's say I pass local date dot now. Okay, so what it is doing is that it is actually comparing this date with this one. Okay, so it is checking that whether this date is after this date. Okay, so let me just print the result. It will actually return a boolean result. Okay, similarly we can do it for others. Let's say I take LT. So in case of LT, you can see I cannot pass a local date here now. Okay, we can compare local time with local time only. That is why let's say I take local time dot now. Okay, and for LD, let's say for LDT, sorry, in this case also I will have to pass a local date time. Okay, so I'll pass local date time dot now. Also, like is after, we have one more method. We have this method is before. Okay, so it checks that whether this local date time is before this local date time. Okay, and what I'll do it, let's just first print these dates and then let's print the comparisons, and also I'll print the local date as well. Okay, so that you know what exactly is the local date and time. Date dot now. Okay, so this is local time and local date time. All right, let me run this. Great. So you will see the output is false, then true, and then true. Okay, why? Because in this case we have ld dot is after local date dot now. Okay, so what is ld? The local date is 2025 315. Okay, and local date dot now is 2026. Okay, so we are checking that whether this date is after this local date, which it is not. Okay, because 2025 is before 2026. All right, similarly for lt is after, here we are checking the lt is 183750, but the current time is actually 10:08. Okay, so this is actually, this is, yes, this date is this time is after local time dot now. Okay, that's why it returned true. And in the last case for LDT, the current the LDT is actually 2020, and you will see that the current date is 2026. So that is why here we have checked that whether it is before. So yes, this local date time is before this current date time. Okay, so that's why this also returned true. Okay, so this is how we can also make comparisons between dates. Now there are two more important classes in this package, duration and period. Duration represents a time-based amount, whereas period represents a date-based amount. Duration is compatible with local time as well as local date time, whereas period is only compatible with local date. Alright, let's see it in practical. So I have already taken this example. I have created a start date, end date, a start time, end time, and similarly a start date time and an end date time. Okay, so now how can I create duration? I'll simply write it like this. Duration is equal to duration dot between. Okay, so we have this method between that we can call. Here I will pass the start time, and in the second argument I'll pass the end time. Okay, so now what exactly is duration? Basically we want to calculate the time between this end time and this start time. Okay, that is what duration represents. Okay, so I'll just simply print this system.out.println. What I can do is I can just simply print duration dot to. Okay, I'll just show you duration dot to. We have these different methods. Okay, so I want to know the time difference between these two times, and this is where I specify in which format I actually want them to know. I want it to know. Okay, so let's say I do dot 2 hours. Okay, now if I'll print it, okay, so it comes out to be 9. This means that these two time have a difference of 9 hours between them, and as you can see that is the case. This is 18 and this is 9, so the difference is 9. Okay, but I could have taken this difference in the format of minutes as well. Okay, and it says it gives me the exact minutes, which is 569. Okay, so the difference between these two time is 569 minutes. Okay, similarly I could do it for seconds as well. Okay, I'll just show you that as well. Okay, we don't have seconds, I guess. We have nanos and millis. All right, cool. Okay, so this is how we can create a duration. Now instead of start time, I can also take a start date time and an end date time. Okay, it is compatible with these as well. Okay, so if I'll run it, great. So you see that it works fine. Okay, so these are the dates, these are the date times, and this much is the difference in minutes. Okay, so I'm not going to calculate it, but yeah, this is the difference. I could have also taken it in hours, and yes, in this case I could take it in some other format as well. I could have also taken it in days. Okay, so now if I run it, okay, so you'll see that the difference is 193 days. Okay, between these two, start date time and end date time. All right, similarly we can create a period object as well. Let's call it period is equal to period dot between. Okay, now here I can pass a start date and an end date. Okay, and similarly I can just print system.out.println period dot get days or get months or get years. So this represents the difference in terms of date. Okay, so here we don't have the time component, so we are saying the difference in terms of days or months or years. Okay, so that is the difference between period and duration. Duration is basically representing time and period is representing days or dates. Okay, so let's say I do get days, and if I run it, great, so you'll see that the difference is 16 days. Okay, so between these two dates the difference is 16 dates. If I would have done get years, okay, then there is no difference because they are in the same year. Okay, but let's say I change it to 2026. Okay, now the year is 1. All right, so this is how period and duration works. Now we have another very important class inside this package, zone date time. Zone date time represents a date and a time along with a time zone. It is used when you want to handle date and time across different time zones, like scheduling events globally or working with users in different regions. Okay, so let's see. So I can just simply use this class zone date time. Let's say I want a default zone, and I can just simply call it like this, zone date time dot now. Okay, let me just print this system.out.print. Okay, let me call it default. Okay, default zone. So you will see that it has the date component, the time component, as well as the time zone. okay, which in this case is Asia slash Kolkata, because the default zone for me is Asia slash Kolkata. Okay, similarly I can create a zone date time of some particular zone. So I can just call it like this. We have a class named zone id, and here I can pass the zone id of some particular zone. Okay, so let's say I want it for Europe. Okay, I want the London time. So let me just create this inside some variable London time. Okay, great. So now this will represent the time in Europe slash London. Okay, similarly I can what I can do is I can just change a time to a different time zone. So we have this method with zone same instant. Okay, here I can pass zone id dot of, let's say, America slash New York. Okay, so I want to convert this London time into this America time. Okay, so now I can just take it inside some variable, let's say US time. All right, let me just print this as well. System.out.println US time. Okay, great. So you will see that this was the India time, then this is the London time, and now this London time was converted into this US time. Okay, so this also we can do using this new date time API. All right, so these were all the important features which were introduced in this new date time API. I hope this video was helpful. For more such content, please follow my channel, The Curious Coder.